Okay, so let's start. We plan to have it in German, but exclusively only for Koen. You're our special guest from Belgium. That we switch to English. Koen, are you there?
Yes, it's appreciated.
Okay.
Just wave to the camera.
Yeah, nice to have you all here. We are going to talk today about this story, meme, metaphor, picture we often read and heard is a blockchain, a real database. And today we have a cross-community meetup or virtual meetup with Coding Earth. Stefan Adolf. He can talk about himself a little bit later. Nyen Wu. I'm organizing here a blockchain crypto meetup in Mainz since 2.5 years, and today we have the 30th, so 30 meetup since then. And with me today on the same room and also virtual room, Christian, who joined me in. Joined me I think 1 year ago, and he's also an early member of the meetup. He helped me a lot during the time. Then he became the co-organizer, and yeah, that's the story. And maybe Stefan talk about or present us or shortly about Coding Earth. What is Coding Earth?
Coding Earth, I'm not exactly sure if some people of Coding Earth are here. If you are, you can shout while I'm talking. Coding Earth is a meetup community that we have founded maybe, I don't know, 2 or 3 years ago in Berlin, actually. This is why I'm wearing that very funny t-shirt. We already did lots of meetups in Stuttgart and in Leipzig and lots of them in Portugal. But since I announced that this meetup today is going to be in German, I guess not that many people are joining because our meetups always are in English. No, it's a little bit late to re-announce that. No. Coding Earth is about coders, and we try to pick a different topic and we do this meetup. But well, since most of our organizers are in this whole blockchain space, you can imagine that we usually have also blockchain topics, and this is why I am here today, to support you with, let's say, coding knowledge.
Yeah, maybe about yourself. So I guess you're a developer. You sneaked in to be a developer, or you in your previous life you were a lawyer. Maybe Koen, for example, he has different specialties. He is a lawyer, but he has also a developer background and economics background. So what's your story?
It's a really long story. I once have been a startup founder here in Berlin. I even made an exit back in 2007, but this is a really long story.
Okay.
It began with me being a mathematician. So I got a diploma in mathematics, but unfortunately I forgot all of that. And since 2002, I think I'm writing software, sometimes more, sometimes less, but in the last 10 years, I'd say I'm mostly concentrated on software development. I'd say, yeah, I've been working for Samsung, wrote lots of Java there. I built lots of PHP applications. And since 8 years, I'm more or less in the JavaScript, TypeScript universe. At the moment, working for a brilliant company called Turbine Kreuzberg, which is obviously from Berlin. And well, we're an agency, and we also have 20 people working on decentralized technology, I say.
Lovely. Okay, great. So I think we can switch to the next slide. Christian, you would like to talk a bit about the background story, why we come up with this topic.
Right. Thank you, Nyen. So it was a really cool call we had together. Nyen and me were together with Koen, and after some time we came to the point, or to the question, what a blockchain actually is, or even deeper asking what a database is. I think Koen had also great ideas about it. We talked about what a database is on a low level kind of thing, just data or just some storage on some disk and things like this, and or on the high level, at the high level, we could say that database is some kind of software that can push data into some place and retrieve it. And because of this, because we were some kind of, yeah, well, how can I call it? We didn't come to actually good definition. So this was the post I posted on Twitter just to ask the community what they think, what a database is and what a blockchain is. So you can read it here. The results were pretty amazing, I think. And also you can see a lot of comments from Stefan here. So Stefan, for example, just answered, blockchains are usually referred to as ledgers, which in my opinion, more or less is an accounting log. There's not much of a database in them besides taking it by its name, a base of fundamental unchangeable data. Add smart contract and you get stored procedures and state machines. When we get to the top of the answers, we see something for not going back to normal. It's Ali Pasha. So he answered absolutely. So basically you start with math, relational algebra. When you come to the point, data structure and algorithms, linked lists, code implementation details, and after that you come to the point blockchain. I think I don't have to read through all of it, but I think when you take a look at it, you can see there's a lot of confusion, I would say, what a database actually is.
Lots of opinions, right? Everybody got something to say on that topic.
Yes, right. And at the bottom on the left side, you see also some reply from Kuhn. Here, Kuhn, you answered, looking at history, I would go for a way to structure data and persist it with the purpose of retrieval on a later point in time. So mirroring clay tables, storing the amount of a grain a field produced are databases in my opinion. So it's also a funny approach to this question, what a database is. But after some time, Stefan, you can go to the next slide. We just came to a point that we told us, yeah, why not making a whole meetup from all these answers, or make a meetup about the question, what is a database?
There are two questions in there. What is a database, and also is a blockchain a database?
Yes, right.
You mean there are two questions that we have to answer now?
Well, not at the same time, but it's a bit double. You have this opinion like you voiced. It's a ledger. So is a ledger then a database? Is it the same or not? Most people I know would freak out when you state that the blockchain is a database. They will point to CRUD principles: create, read, update, delete. That's not a blockchain. True.
Yeah. I'm glad that you're bringing that up, because guess what? We prepared something for you.
But so we can, I think we can switch to the next slide.
Let's start with the beginning.
Yeah. So I'm not going to a definition of what a database now is, and just want to give an observation. When you look out there in the news, in the media, in different references we find online. This is, for example, the Gabler lexicon about economics, and they have their own definition. And you always find this, a blockchain is just a decentralized database and a network with a lot of machines. We can switch on to the next one, and then we have here example is from the Bundestag here in Germany. They have an own PDF and paper, so I will share these slides later on with a link to resources. So the Bundestag has an own definition, and you see here they use a DLT, and you have also find, there's the decentralized, also verteilte Datenbank, decentralized or distributed database. So there's now you see there's a difference. On the one hand, we have decentralized, here we have distributed database. And when we go to the next one, here we have from a university in Switzerland, and they call it also a distributed public blockchain database. And the next one is from the FAZ, a German newspaper, and we also have here an additional property. It's a crypto or secured database, decentralized network. And when you look more out there in all those big newspaper, you have on the New York Times, Harvard Business School, all these great expert networks of people, and you find database is always there. And the question is today, is it really the case? And then I would like to ask you guys now, we can switch to the next slide at the end. Yeah, what do you think? Is this, do you have any opinion about this statement? So maybe everyone give a short, their own opinion or observation. Let's start. I just pick some random people. So Sam, I take you.
Very random.
Yeah.
I think for me, starting from the blockchain, I don't think it's a database. It's a log, and the log is not necessarily a database. And like Kuhn
Yeah.
said, it also doesn't allow you to delete something, at least, besides Ethereum. That's the answer to blockchain. For me, it's not a database. And the question, of course, that I never really went deep into is what is a database? So I think that definition, of course, is important to say it is not. But generally, Kuhn said the right thing. When I hear database, I think of something where I store data, but I can also retrieve it and reuse it, and I can delete it. And there are certain of these things that I cannot do with the blockchain, at least not with the public blockchain concept of Bitcoin. And I think the big issue of our times is really that we live in an era where things happen so quickly for most people. We're now deep into this blockchain thing, but we have no, knowledge of maybe genetics or whatever. And so these memes, these really memes, not really even concepts or any proven thing, just memes keep growing and living, and are living. Even if they're proven wrong, they still live on, So we have this thing that people simply cannot differ between decentralized and distributed. It's impossible in the community itself to somehow, after I don't know how many years, to get people to start using these words in the way they are, in the way they make sense. Yeah. And so I think it's the same with this decentralized database. It's just bullshit. For me, it's bullshit, but it's understandable because it helps people to understand the concept of blockchain in terms of it's a distributed, system that is not on one single server. So cool. Sorry, that's it.
Thanks, Sam. Let's continue with Frank Sims. If you would like to have an opinion, share with us. Otherwise, just let us know that we can skip you.
No, not at this moment. Do you hear me?
Yes.
Okay. No, not at this moment. I just want to listen to you.
Okay.
I want to learn here something from you.
Nice. All. Okay.
I say sorry. I don't. I hope you don't hear that I'm eating something. I have forget to mute my micro.
Oh, we heard that. But no, you can
okay.
No problem.
But you have to pick the next person.
I don't want to make you hungry,
Guten Appetit.
Thanks.
Okay.
I mute.
So, okay, Frank, pick the next person.
Next person. I take Christian.
So you're taking me, right?
Yes, Christian Gauss.
Okay, so interesting. Yeah, in my opinion right now, then could you switch off, or can you mute yourself? Yeah, right, so now I can hear. I don't listen to myself, it's better. Yes, it's a really good question. I don't have a final answer right now, I think, because we had also already this conversation on Twitter some time ago. So they're different. Yeah, now you can see that the answers here. So we've got different approaches what a database actually could be. And I think the term database is evolving over time. The definition from now is totally a different, I think a different one we had 20 years ago, or a different one we had 30 years ago. Because at the beginning, when you think about some computer where you've got some data on it, and once you were able to do something with it, it evolved to some kind of not decentralized, distributed systems where you have also replicated data across some different countries, across different computers and servers. And now you have got different concepts like master-slave concepts, where you copy all the data from the master to the slaves, and when you're changing something in every copy of the database, you're changing also something. So at this point, you could speak about consensus, for example, and when in terms of blockchain or Bitcoin especially, you've also got different consensus algorithms or methods. And so from my opinion is some kind of, it depends on the definition we have. If you define something that you could put data in it and we store it, retrieve it in some way, you could maybe say that the blockchain is a database. But when you go back to the definitions of maybe the asset transactions or good operations, you could argue that a blockchain is not a database. So I'm also, like you, all of you guys are totally open to the end of the discussion where we hopefully will get some answer. Oh, I picked the next one, I think. So who can I pick? What about Charles Andreas? Do you want to reply?
Oh, yes, I hope you can hear me well.
Yes, we can.
So yeah, thanks for selecting me. But yeah, I'm also today in this call or in this meetup to learn something. My first opinion was, of course, blockchain is a database, but now I'm not so 100% sure if this still is my opinion, because now I'm a little bit unsure and insecure if this is yeah, the right definition. If I see this CRUD as an let's say definition for database, then I would say that yeah, I still have to learn some more about this topic.
Great, that's why we are here. We all want to learn.
Exactly.
So can you pick the next one, Andreas?
Yes, so Samater, I'm not sure if I pronounced your name correct.
Sam was already
yeah,
he was
sorry.
there.
Okay. Yeah, it's Samata and Sam are the same.
Okay, who wants next? Stefan?
Yes. Oh, wait, sorry, me or the other Stefan? I don't know.
No, I think I go last for a reason.
Okay, so this is an interesting question. To me, actually, the more interesting question is, what is a database? And because I think that data is just, it can be numbers. Numbers are figures, right? So to me, actually, I think that blockchain is a database. At least that's how I understand it currently, because you're saving data or information in a specific place that can be read at a later point in time. So you're not actually, okay, you can't delete information, but to me, is that really a necessary element of a database. I don't know. And to go one step further, I really like Kuhn's kind of explanation of the Sumerian clay tablets, because I think actually anything, like let's say you're a geologist and you find a fossil in the ground. Okay, the fossil or whatever the rock layers in the ground, they do contain information or data about the past. So in that respect, I think anything that stores data or information that can be read at a later point in time could serve as a database. So it's really a tricky question in my opinion, and yeah, that's kind of my contribution. I don't know what you guys think about that, or
yeah, awesome, thanks. So just pick the next one.
How do I? Okay, hold on. I'm not sure if I can see everyone in the group. Wait, oh yeah, okay. Hold on. Ferdinand, have you been before?
No, I haven't. So yeah, hi. Yeah, I'm. Good evening, first, everyone.
Hi.
Yeah, I don't really know much about blockchain. I only like read some articles now and then, and heard colleagues talk about it. But I would really much support the things that Stefan said, because to me it's about being pragmatic, and of course you can store data, but if you say we have an application, we need a database, you probably don't need blockchain. But like just a simple database. So that's the way I would look at it. But yeah.
Yeah. Cool.
So maybe who wasn't?
I think Marius and Ronald and.
Yeah, then
cool.
Let's go with Marius, if you have something to say.
Thank you. Yeah, I don't have that much to say. Just one opinion. Like, one thing that I don't like is that we speak about blockchain, like blockchain technologies, in the same name as like the data structure blockchain. So like a list of hash chain blocks. And I think this is part of the confusion, probably why there is so much like talk about it. I don't think like, of course, blockchain as in a chain of blocks is not a database. I think the concept of like blockchains, as most of you used it today, as in a system where you can store data and synchronize data on different nodes. I think this, in my opinion, is a database. It has like all the algorithms that we have in the databases, like all this consensus research that we can now build on, like the protocols, the protocols we use in private blockchains, or even some public blockchains, are based on the research we have from databases. So like this Paxos algorithm is like one of the first consensus algorithms to synchronize data between databases. And so yeah, I think in a sense I would categorize them in the same category. But one thing I just thought about is that even though blockchain is I would say blockchain is a distributed database, or a decentralized database, it's funny that we even have that we need a database on each node to store the data for the whole database. So Yeah, there's some recursion going on there. So I don't know if anyone has some thoughts about this.
I really like your well thought words because there are some additional ideas, right? Like the last one you mentioned, it's self-pointing technology, but I think we will have it. But thanks for your input. It gives additional perspective on all of it, because I know that you are pretty deep into Ethereum. So let's continue. Marius, pick the next one. So we have Koen and Ronald left.
I think Kuhn went, no?
No.
I don't know, but I would pick Ronald. So
Damn.
Thanks. Yeah, well, I'm basically also in for to get a better sense of what that actually means, because in the end I would spontaneously and a little bit more provocative, I would say, okay, who cares? So if why is it relevant? Is it a database or not? If it creates some if it creates some use and it helps certain people or whatever, whoever wants to use the technology, that's fine. So maybe the question for me then also would be, so if it is a database, what can, or if we answer that question, what would that mean? What could we learn from this, and could we use experience, whatever, from the database field, for instance, and replicate it in a way in the blockchain space? So, or is it just academic that we say, okay, it's one, or it's a database or not? So I don't know. It's these are just these thoughts, and I'm really curious to hear what we discuss further on this. Thanks. Okay, and now Koen, please.
Well, so I also like your point of view there. It's a bit a utilitarian point of view. Like, it doesn't matter what the name is, as long as we can use it. So is it academic? To a certain extent, yes, it is an academic discussion, and perhaps not even academic. But if you look at all the mud that is being thrown around on Reddit on whether it's a database or not, then it seems to be an important question. So most presentations about blockchain start, either they say it's a database or they say it's not a database. So I think it makes sense to have a discussion and better understanding, or maybe just agree to disagree on different viewpoints on whether it's a database or not. The discussion originally comes from a discussion I had with Tim Swanson, the former head of research of R3 and now a consultant to Clearmatics. When he said, I don't like the word permissioned and permissionless, they don't cover what it means. And then we started thinking about other things that don't really tackle the question at hand, and well, databases were also there. So let's see. For me, data would be anything that is worthwhile storing more than once. So it's something that you standardize to keep track of it more than once, and you store it in a place where you can retrieve it at a later time. So for me, a blockchain would be a database. It would have a few special peculiarities, like it's hard to delete data, but not impossible to delete data. You can, it's easier to append data. You cannot update data. That's a difficulty. But are these things, like Stefan said, is it really essential to have a database to be able to update data, like wipe out the past? That's basically the human readable, or the how people speak about an update statement. You change the past, or you change something that was registered in the past. So yeah, for me, data is something that is worthwhile storing more than once. So you make it, you define a standard on how to store it, and then you store it in a standardized place so that even when you're dead, people can still look at it and go back. Now the question on whether we talk about the blockchain or blockchain technologies, or whether every blockchain is a blockchain, that's also very relevant, and it makes it more difficult. You can indeed say that Bitcoin blockchain is a time-based series of blocks of data that are connected to each other using hashes. But then again, that's on a pure technical level, and you could also say from a more conceptual or philosophical level, it's a database because you store data that you can retrieve at a later time. But it's totally different as a concept from the database, like from a blockchain like Corda, for example. So it's well, I don't have a golden bullet here neither. It's really good to have a discussion with grown-up people about what a blockchain is. Is it a database? Is it not? Is every blockchain a blockchain? Is every database a blockchain? Like I like it when you say it's a ledger, but then I will ask you, what is a ledger? It's a mechanism to store data in a standardized way so that you can retrieve it at a later time. You just call it a ledger, but it doesn't differ that much from a database, in my opinion. Okay, Stefan, I think you were the last one.
Oh, I think I'm the last one. Okay, I got a good and bad news for you. The good news is there are some slides upcoming which explain and pick up most of the arguments we just heard. The bad news is they're all in German.
Yeah.
Now,
it's okay. I married in Vienna, so I'm supposed to speak some German.
Which is good. So the idea is we will definitely continue doing this in English, but so it's quite hard to read German slides and translate them in English. So if some words break on the way, please bear with us.
I'm happy
Okay.
to support.
Is there anything somebody wants to add before I start with the first slide?
So, oh, fuck.
You have to push the red button.
It's a valuable contribution, Stefan.
Yes.
Stefan Adolf, maybe later on, if you could show the Bundestag slide again. There were some things on it that I...
It's a special form of electronical data processing and storage.
Okay. Yeah.
I can understand the German there, don't worry.
If you can understand that, you're done. You're German.
You like this description? So what I personally really prefer is that one, because it's, I think, quite wrong. It's not a decentralized network of encrypted databases. This is bullshit.
Yeah, decentralized network is, yeah.
Yeah. I mean, but this is happening. So if you have like the standard media writing about blockchains, the most hilarious versions of explanations pop up. And
It's the FAZ, guys.
I'm sorry that the FAZ is writing that, but it's wrong. But never mind, it's close, right? And in the end, everybody tries to explain it with yes, it's a chain of blocks, you know, and there is some encryption going on, and in the end, it's just a database, right? This is what most people say in the end. But I would like to start with what is data? And now this is really German, and bear with me, this has no source. The source is my brain. And I think it's maybe not explaining to the very end, but data is structured. Usually you have, I don't know, some kind of scheme in your data, right? If you think about ledgers, this is maybe not even true, right? This is where we already hit the border a little bit, but data is usually also queryable. So if you ask for a key, or if you ask for a certain property of a data set, somebody might respond with the real data. And there's usually more data than what you actually need in the response. Another thing is data is usually extendable. So this is more or less about the CRUD concept. So once you put some data in some system, you most likely will try or will like to add or at least change it, or you will like to expand the schema. You would like to change the definition of data over time. And of course, you would like to change data in that sense. But the last point, which I put in brackets, is one of the most famous ones, because this is where the term database had been coined. Data is usually relational because people tend to think in relations. We all have a father, we have a mother, we have a dog. We have some place we work at, and we relate to all these things, and these things relate to each other. This is why the term or the idea of relationality is something that's very close to the concept of data. So if you have something to add to that slide, just do it. I think I only spent 30 seconds on it, and currently I'm just reading it. I think there will be lots of more bullet points, and we heard some in the beginning, but these are the most important aspects of data that I came up with. I mean, Christian?
Yeah, what pops up in my mind is the term structured and unstructured data. So, and we could also think in data in terms of information, and information could also be not structured, but unstructured information is some kind of useless for us. So it's also it just popped up in my mind. It's also a cool starting point to discuss about this.
If you think about database systems like Elasticsearch, for example, you can give anything to it. Give it any JSON you can imagine, and the indexer will try to make some sense out of it. And in the end, everything is indexed somehow. And if you search for something, it will respond with something. But still, the data you put in has some kind of schema. Even though every data point might look differently, each data point has some kind of schema. So you're not just putting pure binary data in a database, right?
Again.
Okay.
But this is like against structured data, right? Because it's JSON, so it has some structure. So like I would argue that you have really unstructured data, like I don't know, feelings or something, and you cannot put feelings in the database.
Good aspect.
So, but I think the structure comes with us as human beings. So when you write a query, then you put a structure in it. It can, or structure is also a question of how you define it. If you have only like one column, be it Elasticsearch or an unstructured database, you put something in, but it's still like in a form that you can store it, but the content itself is unstructured, right? So
and unstructured is not really true neither. It's not like it's mangled and mixed.
Yes.
It's not like you had a pig and then you turn it into mashed meat or something. It's not just recognizable for a human, but it's still recognizable for a computer.
Yes.
So is it structured or not? It's not that random. I mean,
maybe you can approach it from the different way of thinking. If you put completely unstructured data into some system, you will never be able to query it in a meaningful way. Besides Elasticsearch.
Yeah, but before it's been stored, right? We select something and want to store it. The content itself is already a structure. So if I have a text, right, it is already structured that we understand it. But the question is what at the end we want to retrieve, and then we define the structure to understand the data. We are actually not able to, we as humans are actually, I'm thinking loud, not able to process unstructured data. We're simply not able to process it. So therefore we actually are, if you look at a picture of a sunflower, you immediately know that this is a sunflower. But from a computer's perspective, this is just a mixed up array of colors. This is exactly what I was thinking about machine learning and deep learning. About, you know, this is exactly the problem or the challenge we you know, IT faced at the beginning, that we tried to we were focused on trying to teach our structures a machine, whereas we learned that sometimes this works like in machine learning, but sometimes like in deep learning, it's easier to get to the result to let the machine find its own structures that we at the end don't know about, but at least the result is what we wanted. So maybe there is no unstructured data if there are humans involved.
I don't know. Stefan,
I have another approach.
Yeah.
Sorry.
Go ahead.
All right. No, but you can also, but you could also have another approach. Maybe we are just humans, and the way our brain works is that we constantly try to put structure in something. even if there's no structure at all. For example, like, you know, the studies like if you drink a glass or if you drink a glass of wine a day, then you're more healthy. Or on the other side, there are studies that tells you if you don't drink alcohol at all and don't smoke cigarettes, then you're most of the time healthy or something like this. But in the end, it's just a correlation. Or where all these results come from can be totally different from how we interpret how our interpretation is. So maybe the term structure is just a human thing, the thing that our brain comes along with to understand the world.
I think it's true. It's also from biological research. It's how people brains tick. You put everything in boxes. And to your point, Stefan, if you show a picture of a sunflower, maybe, but if you show it to an adult of an indigenous tribe in the Amazon, he will have no clue what you're showing. So it's because you recognize it, because you have a box that says flower, yellow, probably sunflower. And that's why you recognize, but that's exactly what Christian says. It's just categorized. If you don't know what's coming to you, you will try to categorize it. And it's how we structure the world to not have to think about everything. There is a study that showed there are about 200 or 200 and a bit combinations to put on your clothes every morning. But still you will do it in the same sequence every day because you don't want to think about what do I put on first. So we structure basically everything we do. And I think Christian has a very valid point that the thing database is actually something that humans make. It's not probably not how nature works, but we do it. We do it with data just to make it understandable. So we don't have to question what is the data we get. We know what it is because we have a structure around it.
Boon, to your point, if you mentioned that you don't know how, I guess we don't know how data is structured in nature. Well, think about DNA, right? I mean, that's basically your genes, right? Your genetic information, and that's structured also in a very specific way in nature. So wouldn't that also be a type of data? I mean, isn't that a type of database as well? If we're talking about structuring data?
Well, it is a database. Huh? It's data you can read at a later point in time. It's just not that easy to modify.
Yeah, you can put some rays on it, and then it will morph.
You can use CRISPR and cut it in pieces too, but it's structure. But would it be random if you just? I've a bracelet here that contains. I have a bracelet here. You don't really see it, but it contains a part of my DNA printed.
Oh, cool.
So it's just a sequence of ABC. What is it? ATG. TCTAG, TCAG, but it doesn't make sense. Huh? It's here. I can read it, but even with the best effort, I will never see.
You don't see a structure in it, right?
No, I don't see a structure. It's just an endless sequence of the same things, but there is something underneath it. So for me, this would really be unstructured data. I cannot make sense out of it.
Only the computer, maybe.
The computer probably can.
Yes. But we human beings not.
It builds a human out of DNA.
Yeah.
So yeah, but,
cool.
but it's maybe a good example because each DNA. So your DNA is different than mine, obviously, but we are not differing in very much. We're just differing by 2% or something. But each DNA is actually an entry in the database, if you want. So if you are keeping a database of all the humans on this planet, you could put all the DNA informations into each row. Then you know you have every human on the planet. On the other hand, you can consider that one DNA is actually a database which is storing all the information you need to build this certain human.
Isn't it interesting to think that actually the natural blockchain would be human evolution, right? I mean, every time it's a new, I guess you come from your parents and it's a new block. So kind of like a hard fork happening every time.
An interesting point here is that I just recently read a newspaper that they are starting to store data in a DNA way. So they're recently, I think on Spectrum, I read it. So just to add that they are working on it.
which is good because it can copy itself biologically. So you don't have to store it on electronic devices.
Correctly.
Which is brilliant. It's a really good idea, but you don't know what's happening if they are replicating.
And if you now look at the slide, it is structured. You can question it. You can elaborate the definition. We can extend DNA. We can put it together. We can change it. Yes. And is it relational? Yes. Even within the string, it is relational. So yeah. It's like a huge database indeed, and it's data.
Cool. You know, the first thing that I usually do if somebody asks me a question which sounds a little bit philosophical, I visit Wikipedia. Do you want to see what Wikipedia is responding to the question?
Sure.
So this is Wikipedia's answer to what is a database. A database is an organized collection of data generally stored and accessed electronically from a computer system. Okay, forget the DNA, right? Where databases are more complex, they are often developed using formal design and modeling techniques. Now, this is really abstract. Now, we could stop here and try to discuss if blockchain is meeting all these requirements.
And is it the same in every language, Stefan? Because Wikipedia is written by people, so it's usually different across languages too, the definition.
I just consulted the English version. If you want, we can try the Dutch one. I don't know. But I mean, there's of course lots of text written under it, and I try to summarize that over the next couple of slides. But yeah, this is what, well, the first paragraph of Wikipedia, well, England, I don't know, is telling us. And I think it's a little bit frustrating because it's not telling us so much about what's really going on here, right? We all have a notion of what's a database, but this is everything that, well, Wikipedia gives us in the first place. So what I did, I tried to figure out, and I tried to summarize actually, this is most of the stuff that's also written on that Wikipedia page, but where is the term coming from? And I mean, if you forget about the DNA thing, this is, I don't know, 1 million years old already? No, oh, sorry, DNA is already 2.4 billion years old, but we're talking about electronic databases. If we could agree on that would be good. Otherwise, we're going to be very philosophical. Yeah. And what I did, I summarized everything that I found on the page. And well, I was also quite a bit amazed. Databases in that sense reach back until the 1960s. And of course, they have been more or less invented during this Apollo program. When people tried to land on the moon, they needed to store data. They needed to keep it in some way. And the first idea that they had these funny names, Code Azure, IBM IMS, and IBM System R. And I think the System R is around until today. So it's, yeah. The more central idea of these databases were that they were linked. This was linked data. It means they had tape drives, lots of tapes, and you had some kind of root node, let's say on position 0 on the first tape. And there you could read something which was telling you which data is in the system. And then you said, okay, I need to find a person called Neil Armstrong. And then you went to I don't know, to the P like person, and this showed you a link to the person database. Then you jumped to tape number 34 and rewinded it to the point where it started with an A. And then you were reading all the names, A, B, C, D, Neil Armstrong. Okay, here we got it. Then you wanted to know, okay, where was he born or something? Then you went to tape number something. So all the tapes were linking to each other, and to gather all the information at the time, you had to jump through all the tapes, and tapes were rotating. So this took quite a while. Really slow. But the basic idea was that all the data was linked. Every aspect of one data set was linked to another tape. Maybe something rings already. This is a really old concept, 1965. Okay, so people started doing that. And then they came up with, I think, nobody knows how to develop software on that. So there was this one person, Edgar Codd, working for IBM. I think there was only one company in the world doing computers. This was IBM, so it's no surprise that Edgar Codd worked for IBM. And he found out that in this Code Azure system that was used for Apollo, there was no search feature. So you could not really search for Neil Armstrong. You had to go through all the persons, find the N, find the E, find the I, and then there was Neil Armstrong. This was really bad. And he came to the idea that's maybe a good idea to order or to organize data inside tables. And he was more or less a mathematician, and the concept of SQL wasn't invented. He invented that actually. So he was a mathematician, and he didn't call it like tables, rows, and columns. He was calling it relations, tuples, and domains. This is, I mean, computer history, right? Mathematicians invented that. But the most interesting thing that he came up with is that every piece of data could be identified using something he called the primary key. And this is something most database developers, of course, today know. There are entities that are formed in some kind of structure, and they are identified by some primary key, which can be a simple number. But this primary key is unique to every entity. And in 1978, this is actually the year I've been born, Larry Ellison's Oracle has been invented, and this is no joke. I think it really has been called Larry Ellison's Oracle. What was it? Okay, I'll just go on. He came up with the idea of entity relationships, and this was leading to this relation idea. So with COD, we only had tables and rows and columns, and with Larry Ellison's Oracle and everybody who was competing with him, we ended up with these entity relationships. So one entity said, my name is Stefan and my bank account has that number, and that bank account, now you go to a different table, had, no, I don't know, lots of transactions, and all these transactions had primary key IDs and so on and so on. So you had relational data. This is 1980, a great century, a great, how's it called? 10 years, I'd say. Decade, a great decade, I'd say. In 1980s, there was not that much movement in the whole space. Microsoft invented these desktop databases like Access. So they mostly put SQL databases or like relational databases in some kind of usable form. They tried to condense the whole ideas from the mainframes to the PCs. This happened in the 80s, but in the 90s, if you have been a developer in the 90s, you will definitely remember that. People started writing code in C++. So everything had to be object-oriented. Well, and this is how they came up with these object relational databases. This was not about tables anymore. Tables were just the fundamental concept how to store things. It was more like, there is an object and it has a relation, and this relation could be resolved. Under the hood, there was, of course, a table. But conceptually, everybody was thinking in objects, talking and interacting with each other. And at that point, you already break up a little bit the idea that so in a relation, every base entity always has a link to another entity. This could simply not exist on some certain aspect of the base entity. So object-oriented or object relational databases were a really big thing in the 90s. I don't know if anybody of you ever worked with them, and I even forgot the names, but this was definitely a big thing. And in the 2000s, just to end it here, there came a totally new concept up, because everybody, me included, hated this idea that I first have to come up with a database structure, with a table structure, then figure out how my entity relationship model is working right. I mean, I already have this XML document. I can just put the XML document in there, and well, they are all same structured, so why should I define a table structure? And this is, I guess, how the people came up with this NoSQL thing. Just put anything in it. In the best case, it has the same structure, but if it doesn't, we don't care. We only fail if you try to query something that is not compatible to the base structure. And in the very end, I think this was around 2007, Neo4j is one of the biggest players. They came up with something called the graph databases. And what? This is why I painted this arrow. Actually, the graph databases are doing something in a much more efficient way, of course. They are pointing from one data point in big graph topology to another point. And this is more or less the same idea that the Apollo people had in 1965. So you see, everything relates a little bit to each other. I heard some sounds while I was talking. Is there anybody who wants to add something? Correct me on something.
No, it's just my wife being angry.
Your wife. Yeah, good greetings from Berlin. I hope she's coming down.
I love the idea, Stefan, that Hashgraph and IOTA are actually things that Neil Armstrong already used.
in that sense. I mean, forget about the consensus. This is coming later, right? But the
Yeah,
idea
yeah.
that data is linked to each other, well, this is really one of the oldest parts of data structures, let's say.
Guys, I'm gonna have to go, but thanks again for the interesting discussion. Is this being recorded, Nyan or Christian?
Yes.
Great. I'll check out the recording then.
Absolutely. I
Bye.
try to make it short.
Thanks, guys.
Stefan.
Bye, Kuhn. Ciao, Nyan. Christian.
So I'm from 77, Stefan, and I grew up with the relational databases. So I even like the idea of thinking about how the data will look like before pouring data into a structure. It's, the relational part makes it really strong in my opinion, but I worked with IBM DB2 and stuff like that. Yeah.
I'm the MySQL Oracle guy, actually. So I also know quite a bit of database technology. But this is not so much about what's good, what's bad. It's more about the idea of relations, which is a brilliant idea because this is close to what people do every day. They try to connect things and put them in boxes. This is what you also mentioned, right? So
I do agree, and it's a logical evolution.
Yeah. But all these concepts had one thing in common, and this was, or at least they ended up with some common concept, and this was the database management system. And I also asked Wikipedia, okay, what is a database management system? A database management system has three concepts that are separated in their systems, but so all of these systems have all these three concepts. They usually offer an external API, so you can access that. In the simplest case, this is an SQL API. You ask an SQL query, you get something back. You have a conceptual, a conceptual layer in it. This is how is the global state of all the data is defined. Is the state running in memory? Is it something that's written onto some data storage like MyESOM or InnoDB or something? Or is it even written into a log, like an event log that is coming up with some in-memory CQRS representation? So this is the conceptual part, but as the user, the external API user, you usually don't care about this conceptual layer. You just say, I need the data. And then this database management system gives you some response. How this is happening is actually not that much of interest for the one who's querying. And then in the end, there's also this internal concept, which is trying to organize data physically on one machine or on many machines. So there might be index tables, materialized views that are speeding up things. There's sharding and built in, or partitioning, so you can store lots of, if you have loads of data, you can store them on different machines in different ways. This is the internal concept, how data is handled on these systems. But the main quote of Wikipedia that I copied here is really good. So, the main thing that came out in the 21st century databases was separating these concerns. So in 1965, as a developer, you would have to know every little detail of these concepts to interact with the database. Nowadays, if you ask a CRUD developer, he only knows SQL. He doesn't care if this is an InnoDB, a MyESOM, whatever, usually. Up to the point where he definitely has to. But in the best case, you don't have to. So, the most great achievement was separating this external conception and internal levels in the last 20 years. So, if I may answer the question that we asked in the beginning, Stefan, was ist eine Datenbank? Now I have to translate. It's a system that makes new information out of older information, and that takes care that I, as a user, don't have to care so much about how is this working internally. This is how I would, well, very simply describe a database. At this point, I would have liked to open a discussion. I cannot see how many people are still here. How many people are still here? Because I only see 4 of us and only the organizers.
We should be 9.
Okay. Are you still with me? Is everybody still fine? Or should I stop talking?
Yes.
Yes,
Yeah,
I think we are 11.
Yes.
Just maybe some quick idea from like the node developers. So we in Ethereum like really have to look into how our databases are structured, because we're really running at the edge of what's possible to write and read into the databases. So in general, I would agree with everything you said, right? For like 99% of the users, it doesn't matter how the database is laid out and how your data is stored, as long as you have a decent database management system. But I think if you look deeper into the core of the blockchain nodes, then you'll find out that this is like a really, really big problem. Probably the biggest problem we have in blockchains right now is how the data on your local node is stored, how it's accessed, how we can update it as fast as possible, and how we can maintain a state without like outgrowing 99% of our users. So
right. So you have two problems on Ethereum. This is storage amount. You cannot store JPEG images on Ethereum. That would be too expensive. So, I mean, if you're just a plain Solidity developer, you don't have to care about, right? So you just write some state in your Solidity code, and okay, you update something. You don't have to need to know if there's a partition Merkle tree running at the bottom layer, and that there's some proof of work consensus securing everything. As a Solidity developer, you don't care. You usually, until the point when you have to, because when it's getting expensive, of course. But from a basic application point of view, well, it's not of much interest, I would say.
I mean, Marius.
Looking at evolution you shared earlier, Stefan, if it is too complex now, it is bound to be made more easy in the future.
Yeah, right. Maybe people come up with better solutions, so you don't have to care about what's going on under the hood. Or at least the compiler says, I don't think this is a good idea. We'll see. So if you don't mind, I would continue with that centralized thing, and I'll try to keep it very short. I think this is also not, there are not that many slides, and I will skip most of them because this is not blockchain related in that sense. But there's one term on centralized databases, or in database, well, history, I would say, and this is ACID. Atomicity, consistency, isolation, durability. I guess not everybody might be familiar if you haven't written transactional applications, but this is how databases have become so popular. If you wrote a transaction that consisted of several operations on the data, this atomicity was guaranteeing you that if you wrote it and something was not good, that it could roll back the whole thing to the old state. This is just, from my point of view, the most amazing feature on ACID compliant databases, which made everything like secure, also on your bank account. So on your bank account, if you do a transaction and you pay 50 euros to Christian and 100 to Nyan and 50 to me, and the last transaction is not working, but we told the bank to execute all three, the bank will just roll back all of them. And they always guarantee that this is always working well. The last, maybe also very important part of ACID is durability. So ACID compliant databases guarantee that before something is executed, it's stored on hard disk. So in case that something goes wrong during execution, we still have the information what we actually should have changed. This is one of the most important parts in ACID compliance. Not everybody's doing that right, I guess, but yeah, this is, well, a main feature of, let's say, classical databases. But there was a point in time, maybe in the 80s, I don't know, where people noticed, well, we cannot just put more CPUs and RAM into our machines. We cannot scale vertically. We have to scale horizontally in some manner, right? So if we have too much data and too many queries and we want to respond in time, we have to scale somehow. And the main idea in this time was scale horizontally. And if you think about ACID consistency, this was really hard. Because if you write something on the one machine and you read on the 30th machine and you want to be ACID compliant, the information that is written on the first machine has to propagate through the 30th machine. So I'm reading exactly what has been written here. And this could take quite long. So horizontal scaling on ACID compliant database is possible, but it's quite hard, and it's quite hard, really hard to scale, and usually gets very slow. So many people came up with the idea, okay, what if we just have one master in that sense? They're historically calling that master. Today, we are calling it the leaders or the primaries. And everybody who wants to write something, who wants to change data, is writing to this one master. And then there are lots of little replication slaves, they call it. Today, they are called followers or replicas. And they are just replicating what has been written on this primary node. And to make that happen, and I even have a demo for that, but I won't show because this is, well, it's centralized database theory, so we can skip that. But the most important thing that's running under the hood on this internal layer are so-called shared transaction logs. So as soon as you write something, the master is of course writing some data in the database layer, but he's also writing a small binary log that's replicated on all the other machines. And they are reacting on the log. And every machine has some state according to the most current log level or log entry that it can see. The logs are propagating through the network, and all the database replicas are dating their state up according to the log entry they see. This is called a transaction log. This is how MySQL is working, how Oracle is working, how Postgres is working, how every SQL database is working under the hood. They are writing transaction logs. Got a demo for that. If you want, I can share that with you. It's quite amazing. Maybe not everybody knew, but this is how they work. So if you want to scale on a broad horizontal scale, and you don't want, and you want to be you want to be high performant, you cannot get ACID. What you can get is base. You can be basically available. You can have some kind of state which you cannot guarantee that is really the latest world state. You can only say, well, we have some state here and maybe it's the most current one. This is the so-called base consistency level. And the reason why this is not working is the so-called CAP theorem. The CAP stands for consistency, availability, and partition tolerance. You cannot get all three of them. You always can pick two, but if you get two to the max, you will not get the third one. So you can get a database that is highly consistent. So it's always up to date. It always shows you if something has been written in it. It always will respond with that value. And you can also say the response time is really fast. So you will get an immediate response. But unfortunately, this kind of highly consistent, super fast system cannot be scaled. You can scale a system to 30,000 machines. And you can say, okay, we want that if I write something here and I ask something there, we respond in a millisecond. You can get that. But then, so you can respond very fast, but what you don't get is the right information. You cannot guarantee that you get exactly the right information. If you want to have the right information, you will never be able to make it fast. This is the CAP theorem. And
just got one question, Stefan, from when you get one slide back. So what you have told us is that under the hood, there are transaction logs. And what we see is some kind of level higher, the results of these transaction logs. So does it basically mean that there's some kind of immutability inside of a typical distributed database? Because when I'm thinking about it, that from a database perspective, it is possible to delete something within the table or to update a field inside the table. But when it is all built up from transaction logs, so you could take a look at the transaction logs and then you could restore the state before. So it's some kind of immutability within the heart of the database.
Right. You can still change things manually on the log. If you go there with a binary editor, you can hack that. But a transaction log is basically exactly what we're going to talk about, namely event-driven systems. So it's definitely like every, so if you have replication, and very simple example, MariaDB, for example, every insert you do is causing one log entry. In the simplest case, it's just logging your query and saying insert something into table something with a value something. This is what's written in the bin log, or in the statement log. And then a replica is reading that log and sees, oh, we have to insert something. So the replica is never watching the tables magically from the primary. It's just following all the commands that the master also has executed. So the master executes first, then he says, here's the bin log, good luck. And everybody executes what he has executed before us.
Okay. Yeah, cool. Thank you.
Yeah, I said there's a Docker container where I can show that how it's really looking like. It's quite old technology. This is why there's no big reason to demo that, but I will share this. This is quite interesting.
If you then compare it with Bitcoin, it's quite often positioned as a transaction log, but it is then the transaction log that allows every node to restore the data, which is a transaction log. It's where we were discussing like self-pointing databases earlier. The blockchain then seems to be a self-pointing event log or transaction log, and not a database at all. It's just a very, very small part of it. Okay, just a wild thought that crossed my mind.
Go ahead.
Cool.
Did you finish?
Something.
Yeah, it was just a wild thought that crossed my mind, so I finished. Yeah.
Oh, okay. Sorry.
Sam,
so
you wanted to
Yeah,
say something?
yeah. I was just reminded, maybe Marius remembers, Vitalik Buterin once wrote or coined the term scalability trilemma. Do you remember, Marius?
Yeah, it's quite known. Huh? You have to choose between scalability, security.
Exactly, and it's actually the CAP theorem, right?
Mm-hmm.
So I didn't know that.
This is, I think it's called differently in their space, but it's expressing something very similar.
Yeah, exactly. It's exactly the same.
It's scalability, security, and privacy, I think, right?
Yeah, so it's not exactly the same.
But this trilemma you have in different other systems. Also, when you it's not in software or databases, but you have also, for example, when you're doing project management, you have also this trilemma in scope, quality,
budget, timing,
and in budget and timing, right? So you have always pick. Can you
golden
speak
triangle, as they call it there.
Right.
So you don't see this. So Marius, you say it's not the same because if I remember correctly, it's security, scalability, and decentralization, and of course consistency is, I mean, what blockchain people mean with security, and availability is okay. So okay. It's
no,
not the same.
it's
I get it.
different. It's another trilemma, but it's different than the CAP theorem.
Yeah. But you have this golden triangle, as Kuhn said. So this is the overall concept that you have in those systems that you have. You cannot pick all of it. You cannot have all three attributes of the system.
I forgot also the name of the triangle, but I know what you're talking about. Otherwise, I would Google that.
Yeah.
Well, the triangle Jan is referring to is the classic Scrum. It's the classic Scrum intro with
not on Scrum, in project management in general,
yeah.
But you will find this pattern in other methods or ideas, not only here in database or storage or systems with availability, but you have it also now in blockchain, as you mentioned, Sam, that you have also picked two of it and one will not work. So if you want to have a fast system, scalability, and if you want to have decentralized and security, one will fail. So you cannot have three of it.
You also have it in business. You have to choose between quality, price, customer satisfaction. You can't have all three of them.
Yeah.
I think trilemmas are everywhere. This has to be related to the universe entropy or something. I don't know. What's going to happen if you could revert entropy? Go to the cinema. So with that, shall we go over to the distributed databases? Because now it's getting really exciting. Since everybody was using bin logs anyway in their SQL databases to get scale, somebody said, well, if we are based on event logs, why aren't we just writing event log based databases? That would make much more sense. because then we can skip all the overhead and build custom, let's say, SQL applications on top of this shared event log. And this is how a log looks like. I mean, this is a very trivial picture, I'd say. There is a 0th record and there is a latest record. And somehow they are ordered in some kind of sense. So the idea of event logs is every write. So as soon as somebody wants to write something to the system, it's first written into the log. This is usually very fast. And then something is happening. Then something is exchanged. Then something is, I don't know, checked or validated. Constraints are checked. But what's really important is first you write it into the log. So everybody who's also using the system can or has a chance to execute the same applications on top of that log data. And actually, this kind of event logging is one of the most original representations of a database state. The event log itself is not a state. The event log is just, well, a long line of things that happened in history. But these are the most fundamental idea how to come up with a shared state. And there's only one thing you need to create state out of event logs, and these are state machines. And the idea of state machines is if you have two processes with the same state machines and they get exactly the same inputs in exactly the same order, a state machine, a good state machine, deterministic state machine, guarantees that the state will be the same on both of them. So a state machine with the same inputs will always yield the same output. The main problem is, how do you guarantee that the log entries are always in the same ordering? Now, there was some very clever guy, but I forgot his name, unfortunately. I think I didn't write him on the slide, unfortunately, but he called it the event log versus table dualism. Tables are just data in rest, and logs are just data in change. So as soon as you stop your event log, you have the state. You can also refer to it as a table. A table is nothing else than applying an event log in the correct ordering. And an event log is nothing else than a backup of each table state in time. That's basically it. And if you're a developer, actually I am, so there are lots of analogies to for example, Git or version control systems. There are different terms for that. The one most common known is the commit. A commit is a set of changes you did to the code base. A branch is just a special ordering of applied commits. So you can apply them in any ordering you'd like. Maybe you're creating conflicts or something, but a branch is just a snapshot of a special application of commits. And the good thing is Git is completely concurrent. Nyan can apply lots of patches. Maybe he's missing one that I already have in a different order than that Christian is doing. And we end up with totally different results, but we all base on the same commit set. So we're just applying it differently. If we all apply it in the same direction, on the same ordering, we always end up with the same code base. This is a state machine. This is what I wanted to say before, actually. The most hard problem besides naming and cache invalidation in software development is there is no real time in the world. Unfortunately, Einstein was right. If I'm talking here to a satellite that's flying 400 kilometers above my head, time on that satellite is different than here. Now, the other thing is there is some kind of minimal granularity in the universe, which makes events undecidable. So there is nothing like a trillionth of a second. There is some place and time that cannot be decided between another one. So there's something like it's happening at the same time. We're sorry, but this is happening at exactly the same time. If it's happening at the same time, there is no way you could order something. But there are other things that could make your clock go wrong, actually. So of course you have network latencies. Everybody knows them. If you have a slow bandwidth and you say, well, it's 1530 on my clock, and the other one doesn't have a watch, maybe you can send a picture of your clock, but as soon as you send it, a second is ticking. So the other guy will see a picture of your clock showing an old time. time is really hard to get right in computer systems. You always have to sync them somehow. And the problem is, if there is no time that we all can agree on at the same time, we have a big ordering problem, because we cannot just write a timestamp on our events and say, yeah, we're just ordering them by timestamp because maybe we want to create an event that's happening as an effect of another event. But we have to wait for the first event to come. No, we don't know if it's still on its way or something. The main problem is really that there is no commonly agreed on clock, even though it feels like that if you look at one. This is why most of these systems came up with so-called logical clocks. They're just counting up and say, this is event number 1000, 1001, 1002, 1003. But now you end up with the next problem. How do you make sure that all these logical clocks are synchronized? If I say 1000 and Jan says 1001, maybe Christian already had said 1001 a second before. And this is why counting is also a very hard problem in computer science.
Short remark for that. Also, Google tried to minimize this problem of time. Minimize, not solving, but minimize this problem by putting atomic clocks in their servers, for example.
Mm-hmm.
But yeah, you can't quite solve it entirely.
Exactly. You have to go to the very roots, but unfortunately, as I said, the universe has some kind of base granularity, this Planck constant actually, and you cannot go below that. So at some point, events are really happening at exactly the same time, and at the same time, you cannot order them only randomly. So there are database systems. Now this is a leap forward, I would say, but there are database systems that use so-called log-driven state machines. So they all keep a log, and this log is replicated. And usually all these events are, well, coming in on some of these servers, and they're all logged one after each other. And they try to find a consensus on what has happened before what. So events may never contradict each other. This is why all the machines have to come up with some kind of common view on how the event looks like. And all these systems usually also come with a so-called state machine. So all of them keep a view of all these event logs. Like I said before, there's this duality between tables or representation and the event log. And they are all running these state machines to have some kind of shared state. The most commonly known consensus algorithms that you will find for these kind of systems are Paxos and Raft. And they're called asymmetric consensus models because they usually rely on that all these machines can at some point agree on one being the leader. If they cannot find that one leader, they will step down, don't accept anything, vote another leader. But they always need this concept of a leader. And this is why it's asymmetric. The leader is actually keeping the real reality. We are at 0.1,950,714. And this is what the leader has to decide. So everybody has this final ordering. How the ordering is actually coming up is what in Paxos, for example, is decided by some kind of validation rounds. And this is really not simple to understand. This is why I put the YouTube videos on the bottom of the slide, and we are going to share that later on. This is more or less, now we're trying to go to the blockchain stuff, but I just want to say, distribution in a consensus manner is a solved problem in that sense. There are lots of applications or lots of database systems using that. For example, etcd is quite a simple one, I'd say. This is distributing values, but even Hyperledger Fabric is based on a Raft consensus. So in Hyperledger Fabric, there is no real consensus, at least not as far as I know. It's just figuring out who heard what before somebody else, and then it's ordering all these events in one big event log. One of the most famous ones is Cassandra. I think it's originated by Facebook. Cassandra is a massively scalable system, so you can scale it extremely well horizontally, but it's really highly eventually consistent. You cannot really guarantee that if somebody writes something on one side of the system, that it can read exactly the same thing on the other side of the system, because this is not simply possible. But what I want you to remember is there are lots of log-driven databases out there, or event-driven databases based on logs. Kafka itself considers it an event-streamed system, or sorry, an event stream So it's modifying data based on the event stream that's coming in. And they all use some kind of consensus. And now we come to why we're actually here. Decentralization. Everything we just talked about was more or less about distributed databases. So how do we make it happen that we can agree on one common state if we are in control of all our nodes? The main problem with asymmetric consensus is you have to be able to find all your nodes. The nodes have to live in some kind of controlled network situation. You have to be able to ping them somehow. So, and you have to be able to trust them. So they have to identify as, yeah, I'm belonging to your cluster. In decentralized databases, the main problem is you don't know all the participants. You don't know all the nodes. And you want that everybody, without having seen them in the first place, can become a participant. And the next hard thing to solve in consensus, and this will sound very familiar to everybody, all the participants can decide on their own if they would like to play along the rules or if they want to break the rules. In Paxos and Raft, it's assumed that all the nodes in the consensus protocol are behaving as expected. Of course, they can go down or something, but if they are up, they are behaving like expected. They are not trying to play tricks on you. They don't give you wrong values. They always will try to behave in a controlled manner. In decentralized databases, we don't know anybody. You don't know if they do that. This is why decentralized consensus works differently than distributed consensus. And in a nutshell, what I would consider them, it is unauthorized multi-master replication. This is what blockchains actually are. These are systems where everybody can write and nobody knows anybody and everybody could decide to try to play wrong. Unauthorized multi-master replication. Now, the funny thing about this kind of system is you remember the state machines that run on top of event logs. Now, you cannot guarantee that everybody sees the same event log due to time differences, due to network outages, due to whatever. Maybe he doesn't want to see the events. This means that in this kind of system, there are lots of states existing at the same time. We only have to agree commonly on what is our common view on the state. Which state are we deciding? And nobody says you need a blockchain for that. If you only want to have a decentralized database, you could use systems like OrbitDB or Ceramic Documents. I linked one of them. I also have a demo for OrbitDB. OrbitDB is based on another system called IPFS, Interplanetary File System. What you can do is you can share a database with the world and everybody can write. They're using so-called serialities on the bottom, so they can even resolve conflicts between the data or tell somebody you cannot write that because you would cause a conflict. And it's more or less feeling very decentralized. Everybody can write, but what they cannot guarantee is that somebody is writing something that you don't want or that's playing against the rules. These systems cannot do that. But for all the people who say you don't need a blockchain to do that, okay, if you say you don't need it, you can use these, but you will end up with some issues depending on what kind of application you want to write. The main problem to solve is the so-called Byzantine fault tolerance problem. And I think since we are here in crypto community minds, more or less everybody knows about this Byzantine generals problem, right? This is exactly what I described before. You have lots of nodes. Some of them could play wrong. And now you can, good luck, study game theory and come up with ideas how to solve that. This is never simple. I just put a diagram of how Tendermint is solving that. And Tendermint is, of course, something different than what's running on Ethereum. But the most simple way to achieve Byzantine fault tolerance is actually proof of work. You only say, if you want to play wrong, my friend, okay, try it. But when you play wrong, and we notice that, you lose money because you have to you have to spend lots of energy costs. So there is no reason to spend lots of energy costs if you want to play wrong, because at one point in time, maybe somebody finds out and then you lose all the money. If you're really lucky, you can get away with that. But as we know, in Bitcoin, for example, we have to have more than 51% of the whole network's energy in proof of work. And
Not
this
really.
is why nobody's, sorry, just a second, nobody's really incentivized to play wrong on Bitcoin. This is why proof of work is working. Yes.
It's not 51%, and so 40% you already have 10% chance to topple the network. So it's slightly different, and the biggest problem there is that you have never a true finality of the transaction.
Exactly.
So you can never.
You can always, maybe there was somebody playing wrong, and then 1 year later somebody finds that out, and we're all rolling back to the version 1 year ago. This is in theory possible.
Yeah, I agree. It's theoretically.
Yeah, at the moment, if we're losing more Bitcoin nodes, it gets more possible every day, I'd say. But Tendermint is a POS-based consensus protocol, which is based on the stakes. This is not really consensus talk, right? This is more about the database aspects. And I'm also, as you might have noticed, not the real consensus expert here, but I can tell you BFT is one of the hardest things to get right. And Tendermint has a very good concept of doing that in a cheap way. And they're doing, or many of the concepts in Tendermint are actually the same as you have in Paxos. So you have these validator rounds, you have some votings, you have stakes that can get slashed if you play wrong. You can even play wrong if you don't want so, because you're missing your voting slot or something. So they have lots of ideas how to make that safe.
But Stefan, this is a good point, because this is actually what I think for a long time now, that actually what Bitcoin solved is not a database. What it solved is finding consensus on a state in an untrustworthy environment, right? Precisely. And this is really, really cool, right? And but this was so cool that somebody had to name it, and had, you know, and then it exploded. And until today, I'm not sure if you can do much more with it, right? Because it's the perfect solution for a really hard problem, but that is very narrow. And now what we are trying, or since I know this stuff, what is being trying, you know, everybody's trying is to transfer this very, very narrow solution, yeah, for coming to a consensus on a state, to stuff like, I don't know, contracts, you know, and it's like you said before, you probably, this is the trilemma probably, but another one maybe, but then you lose what you won, right? And what Tendermint is doing, and proof of stake and slashing, and this is all very, how you say, very, like you said, game theory. This is all very well intended, but I mean, and I've been reading, I mean, I stopped reading this in 2018, but I'm back. But until then, I read almost every single stupid paper, and really, Bitcoin is still, or proof of work-based public blockchains are still actually the only ones that solve it somewhat, right? The others are not even close to this somewhat. Yeah. So okay, I was just thinking that what you showed is exactly what I was thinking. What Bitcoin solved is not a database problem. What Bitcoin solved is a consensus problem.
I even have this here. The reason why there are no smart contracts on Bitcoin is that on Bitcoin there is no state. Bitcoin is not keeping an account which is saying, okay, the current balance of Christian is 200 euros. This is simply not a storage concept of Bitcoin. Bitcoin is using these unspent transaction outputs, which says, okay, Christian may spend 200 euros, but if he wants to spend that, he has to spend all of it. He has to spend 200 euros. If he only wants to give 1 euro to Nyan, well, okay, he can do that, but then he have to give 199 euros to himself. Or replace euro with Bitcoin, of course. Not at extra yet, but we are coming. And what Bitcoin makes different from Ethereum, for example, in your wallet, there is not, in that sense, an account. There's always a list of private keys referring to the last unspent output you had on Bitcoin. So in that sense, you only have this, it's not really a state. You have the allowance to spend some money on Bitcoin, but you don't have this kind of state management, how you came, how you created, or sorry, how much money you currently have. It's just, well, a rule that you cannot spend more than what all the transactions before led to that UTXO you currently have. I hope I'm right with that, more or less.
but isn't that the state? Like the set of unspent transactions is the state of the network. So I would argue that this is exactly the state of Bitcoin, and Bitcoin is not like stateless, as you just said.
It's the chain of all the unspent transaction outputs you have leads to your current balance in Bitcoin, more or less. So you have to read all these transaction outputs until the very first one, so you can identify your current balance. And I'm not sure how they're solving that. And I'm really not I'm more the Ethereum one, right? So I'm not that much familiar with Bitcoin, but as far as I know, there is neither a state tree nor some, I don't know, internal representation that is saying.
There is like you have to, like, miners have to have a collection of all unspent transaction outputs against whom they can check whether a transaction was spent. Otherwise, they would have to like replay every UTXO from the beginning every time. So that there's some, but it's technicalities. So yeah.
Right. Maybe this is just a technical aspect, and I cannot really remember why I wrote it like that, but I'm pretty sure that this works differently in Ethereum. And this is why
I think the point is that it's also a question of definition of whether, if you say it's not a database, because in a database typically you have event log or a table where you have a row and an entry, like in a ledger or whatever, then you can see, okay, in row X I have this value, and you don't have it in Bitcoin. Because you have, if you want to calculate something, you need to go through all to calculate it, right? For validators and for the miners. But for your wallet, you have the lock because you have the private. You have exit with your private key. The rest don't have it. Yeah. So this is my point of view on it, but. So for me also, it's not a state.
Right, because I mean, the way we came here, or I came here, was this one. These event-driven databases usually have this ordered event log that they find a consensus, and they are running the state machine that leads to this table event log dualism.
Well, they are deterministic, yeah? That's not true in Bitcoin, I think. Depending on which transaction has been chosen, if you are double spending, you have a different outcome.
Correct. Yeah, I agree.
Exactly. So you have lots of states at the same time.
But we have to, like, all the honest miners agree on the same state. This is like, so it's deterministic in some sense.
Yeah, but
like
they are not agreeing by talking to each other. They are agreeing on the longest chain, because that is part of the protocol. So they're not talking and saying, oh, I think yours is better.
That's a consensus they reach. It's the weak Nakamoto consensus. Whichever is the longest chain is right. And if you roll back and they happen to agree on another transaction, if you're double spending, you will get another result in the end.
All right. So I think the states of blockchains, there are lots of states, but the more people accept or have seen the longest chain will automatically jump on the longest chain. That's it. And then it's quite likely that everybody can agree on the same state just by looking at the block height, actually. The latest block is winning. And if you figure out that somebody else has a higher block, you jump on his chain and your state is lost. That's it. I guess this is how blockchains are usually coming to a consensus on the longer run, right? Always agreeing on the longest chain of states. Last slide, people. Why I guess that Ethereum is more like a database than Bitcoin. So Ethereum considers itself a transaction-driven state machine. This is the whole idea. There is a state machine built into Ethereum, and all the transaction. So if you apply all the transactions one of another, there's something like a world state that Ethereum is keeping, and this is something that, as far as I know, Bitcoin is not doing. But this world state, I don't know if anybody of you is running a full node on mainnet Ethereum. So if you want to run a full node, well, the sync of the block headers is usually taking, I don't know, maybe half an hour. I've never tried that, but I think it's quite fast. So just reading the blocks with all the transactions and all the hashes and everything is quite fast. What takes really long is creating this world state, because you have to compute all the smart contracts, all the code that's written on the ledger to run the state machine to come up with some state. And you are applying all the state changes with every transaction, and this takes quite a while. And I guess syncing a full node on Ethereum, I said I've never done that, but I guess it's around 3 weeks at the moment to come up with a final synced world state so you can participate in the latest block verification. Don't know if anybody has a different opinion on that one, because I said I never tried that.
I think Marius is the expert. Marius is should be able to answer that.
Yeah. So yeah, so it's true that if you execute every single state and save the intermediate states. So this is what we call an archive node in Ethereum. This takes 2 to 3 weeks depending on your setup. You can have a full sync in a weekend, or around a weekend. So this is executing every state, but not saving the intermediate states. You can have a fast sync, which is just checking, like downloading all the old blocks until I think 30,000 blocks from the newest block, and from then on you execute every transaction, like every transaction. And then we currently rolling out snap sync, which is even faster. So this is like super fast. It's like 50-60% faster than even fast sync. So this is like some new feature that's hopefully coming
but
soon.
you still have, I mean, I think the main thing you have to do, if you want to, let's say, run a productive Solidity code on that, for example, and modify the state, you have to know what's the old state. This means you have to create the state. Creating the state means run the state machine. And to be very sure that you're on the latest state, I think you have to run it from Block Genesis.
Well, you can, yeah, but you can also just download it from someone.
Of course, but then you have to trust them somehow.
So when you say, Stefan, there's only one global state, what I never understood in Ethereum, actually, to be honest, was this uncle thing.
Oh my God.
Maybe Marius, no, but what I understood is there is like something like, you know, the longest chain issue, but Ethereum has taken another solution to solving it. And as far as I understand, you still get something for these uncles, which are the orphaned parts of the blockchain.
If you're so unlucky that you're living in a place in the world where the internet is so bad, but you're running the largest mining rack you can imagine, you're still incentivized to take part, even though you're not winning. We're sorry, but you can still get money for a correct price.
Okay. So that's really okay.
Wait. This is how I understood.
Okay.
I guess you have better explanations from someone.
No, this is exactly what I understood too.
Yeah, I also
knows better.
This is it.
No, it's perfect. It's a perfect explanation. Like, you're incentivized to run your miner even if you don't have like the super fast internet. Like, for example, the big pools, they have servers all around the world, so they can fast track their blocks into the network, so they can be distributed as fast as possible. And having this ghost protocol, like including the uncles, is what allows Ethereum to have block times as fast as like 13 or 10 seconds or 13 seconds or something like this. compared to Bitcoin with its 10-minute block time. Because like in Bitcoin, if you lose your block in Bitcoin, then you're down 100,000 euros or something. So it's really bad. But in Ethereum, if your uncle gets included, you get, I think, 7/8 or something of the block reward.
Which is quite
I'm not sure, but
what is the block reward on Ethereum at the moment?
2 Ether.
Oh, okay.
So, but but currently in the whole DeFi craze, we've seen block rewards up to 14 Ether because of like the whole transaction costs. So it does make sense right now to mine Ethereum again. So if you have a rig laying around, then go for it.
So just to close this with a final statement so we can discuss that one, I just want to skip to the very last slide. And I actually wanted to explain all these 3 things, but I must really admit it's now 2023 and I don't even remember everything on my own, but I read everything. If you want to read all the stuff that leads to this kind of stuff, I linked the headlines. So there's a great article on what's what, and if you're really interested. I even set up a Geth node and tried to show you on LevelDB how this looks like binary, but I mean, it's not exactly helping you, I guess, at the moment. This is why I'd like to go to the last slide, where I personally would try, after 30 slides now, to answer the beginning question. Is a blockchain a database? At least this is how I understood the question, right? So what a blockchain is in the first place, it's a distributed or decentralized BFT consensus mechanism that is ordering transactions. This is why there are blocks, right? Blocks are just is a cryptographically secured collection of orders or of ordered log entries, transactions. If you apply all these transactions in the ordering that has been written in the blockchain, they lead towards a system state. You could consider that system state a table. But the state is actually stored next to the transactions, as I just said. Usually you just download the block headers, you can verify all the blocks are great, but you don't have the state. You have to create the state, well, on your machine, on your node, if you have the time and the CPUs for that. So this is why I personally would like to conclude a blockchain is not a database in the original sense, but you can use it as it was one. Because of course, in the end, you will end up with that event log table duality. So you can read from it. You can even modify something. You can never delete something, but you can mark something as deleted. But it's not a database in the usual sense that is managing data without you knowing anything about the inner workings. This is actually my final slide and my final words on that topic. Thank you.
I've got one question.
Yes.
Okay, you have already mentioned here that it's not a typical database, since this the so-called state is just produced on your own machine, right?
Mm-hmm.
But when I think back to some slides before, to distributed systems, you have also got some master nodes and master and slave nodes, right? And all of these different nodes are also reproducing the state on their own. Am I right?
They all keep at least this. Yes, they're stream processing. But for example, in Kafka, you can advise only certain nodes to process a certain partition of your event log, for example. Mm-hmm. So not everybody's keeping all the state. It's up to you as a user, which events you would like to read and which ones you would to consume, or which partition you would like to listen on. In this global consensus, there are actually only events. And of course, it's up to you what you make out of the events. But I would really like to define blockchains more like the consensus part of it, like the ordering part, like Satoshi Nakamoto also, this was his idea. He never talked about a blockchain, right? He said, we need to order events somehow so we can come up with a common state. This is the main idea of the blockchain. And this is why it's not a database, because it's not really, well, tracking state with it only if you wanted to do so.
I just still have in mind this state machine thing, because I think I haven't really understand why Bitcoin isn't a state machine, because state machines are about being deterministic, right? So when we've state which is produced from the Bitcoin blockchain, is it produced from? It is produced from the largest chain, I think, right? So when we are looking at a system, it should be that all participants are agreeing all the time to the same largest chain.
If you find a higher block than the one you know, you can accept that block as your valid chain. But if you find another larger block, you accept that one.
Yeah,
or everything that comes behind it.
Yeah, of course. But I mean, this is like the chain or this kind of tree thing in blockchain is growing and growing. So it's about it's about the amount of participants agreeing on the largest chain. So isn't it in the end just a definition if it's a state machine or not?
Yeah, I mean, state machines are built inside most of the blockchains in some way to come up with the table, right? The state machines are creating the table for you where you can do your queries on. And as said, I think in Bitcoin, you're not really like keeping track of that state in that sense. You're just getting a new unspent transaction output, right? So this is just.
I would argue against this. Like from my point of view, in Bitcoin, you like when you receive a block, you execute the block. You check whether check or whether you spend transactions that have been unspent, and if the signatures are all right, and you check the proof of work. And I would argue this is a state machine, and then you update your local state to include the UTXOs that like to remove the UTXOs that have been spent, and you add the UTXOs that have been unspent, and this is your state of the network, and everyone has to do this if they want to sync the node. So I would say that, like, I think from my point of view, Bitcoin has a state. Like everyone has to have the state if they want to see the UTXOs. And
but it's not one state. It's not one state. There are different nodes running different states. It's just the longest chain that will win in the end. So you have hundreds of Bitcoin forks. They usually only last one block or something, but there is no real one state. If you would poll a single machine, you don't really know whether you're looking at the right state.
Yeah, but then you cannot say that Ethereum has a global state, because Ethereum also has small forks that reorg and that like. So I don't see why there should be a difference between the two systems.
No,
I think both of them have a state, and every block does something with the state, modifies the state, and of course you have to roll back sometimes. But I don't see why some of them should have a state, and like why Stefan that way, but it's okay.
I think in the discussion of states now with Christian and Marius, I think what you have to separate is, on the one side, the state of the current of just now, the block, right, and the state of the blockchain itself, right, of all blocks, because I think if you don't separate these two in the discussion, you are talking about different. My feeling, it turns into a discussion about different things, because in the one block, you like I don't know who said it, Kuhn, you have, regarding this one current block, the newest one, you have many different states in the network, right? And so there is no state machine in that sense. Yeah. So, and with time growing, like we used to say, Bitcoin 3 to 6 blocks, right? So half an hour to an hour. With that time frame, you get the confidence that unless something happened, your transaction probably is real, and it's been accepted by the network as a state. There's a consensus on this state of your transaction, right? So at that moment, it turns into something that is a state machine. But at the end, both Bitcoin and Ethereum, I think Vitalik said it once in 16, 17, they never reach 100% finality. So the state is never 100% true, right? Excuse me? Sorry? So that's how I, okay. So that's, yeah, I think if you have to separate the single block, there it is not a state machine at that moment, or there is none. Yeah? And once you have this finality kind of puffer, what's puffer in English? This time frame you need to wait to have a good feeling about finality. That is where actually the state machine starts kicking in.
Okay, but I have to add something to that, because when you're thinking again about distributed systems, there are also some inconsistencies in the information all the replicas has got. So you can imagine that some of the replicas haven't got all the logs. So at this specific time, right, at this specific time, they all got different states. It's like that. That's the difference between Bitcoin network in this sense, from this perspective, and the distributed network is just that in a distributed network there's some kind of ruler. This is the master node that tells you what's the truth. But you can, and I think it's just, so in my opinion, it's just a definition, a question of definition, because you could also say that in a Bitcoin node network, you're just replacing the master node with some kind of the whole consensus mechanism in Bitcoin. So it's just some kind of an abstraction layer from this point of view.
Yes, but okay, but yeah, what I was trying to say is this is also the difference to the master solution. The master solution is final, right? It's once the master decides this is the state, the network, listen to me, here's your state, everybody says, okay, that's it. In theory, in a blockchain proof of work kind of concept, this is not possible. It's, you know, it gets how you say, more probable. Yeah, the more time moves on, but you never reach 100%. It's like 99.999. But in theory, there could be one Bitcoin blockchain running somewhere that takes over, and all our transactions are gone.
But wait. I could also build some theoretical situation up in a distributed system. When we have got some distributed system where the leader is voted, there's a vote about a leader. So there's one leader that rules the whole system, but this one can die. So another leader will be chosen. So now you can imagine a situation where there are a lot of consistencies, and the leader dies. So another is picked or chosen, right? So what he is telling you, he's telling you his truth of a network, but he could also die, and so another node has got the truth at the same moment. So in this specific situation, it's also like there's no finality, because there's also a possibility that a leader could die.
Yeah, but I think yeah, okay, it could, but I think in these systems like Hyperledger and the others, I think you have some very how you say belastbar, some very hard contracts that solve these kind of issues before. Like Stefan said, they are known in a known network, and yeah. But I understand what you're saying. In theory, yes, it's the same.
They actually also just have a very well-defined consensus protocol. They say if we lose our leader because he's not responding, then we're voting a new one. And in Raft, the first rule is you vote for yourself. And then you tell, I'm the new leader. And everybody else also says, I'm the new leader. And the more people hear someone shouting, I'm the new leader, they will start to follow him.
Yes.
So this is the idea. The leader can go down at any time. Otherwise, they wouldn't be distributed in that sense. So you never have to trust that there's always this one machine running. It really can go down. This is okay in Raft. It's more about the replication and the agreement on the ordering and what's the worst case. And this is related to your blockchain, longest chain exists twice idea. There could be the case that, let's say, one half of the network is simply not listening to the other half of the network. And suddenly the leader goes down, and in exactly that moment, both networks are connected again. And then suddenly all the nodes of one half of the network listen to the leader of the other half, which they haven't seen for half a day. And now they will all roll back all the event logs they have read and will replicate all the event logs from their 50% other people. This is the worst case, I guess, that can happen in Raft.
Yeah, but these are all theoretical situations. The practical, how it's called, Daumen thumb rule, but the practical rule of thumb rule, I don't know.
Rule of thumb, yeah.
Rule of thumb. The practical rule of thumb in Bitcoin is, I think, 6 blocks. After 6 blocks, you're pretty sure that there's some kind of finality in your transaction. So it's, I think, the same thing like with a leader dies situation in a distributed network.
Yeah.
In a decentralized network, you never know if somebody is there doing something completely different than you, because you don't know the nodes, right? You can, but I think there is in proof of stake, you have this instant finality, where you can say, I don't know, as long as a majority of nodes provable has voted on this ordering of events, you can be sure that this will never change.
I think in Hedera Hashgraph, it's the case. You've also got Byzantine fault tolerance, some kind of it. And they've got finality, I mean, really 100% finality after some votings.
Yeah, exactly. They also have voting rounds and the steps, right? And they try to figure out if someone has participated in the step. If not, they're dropping it. I also have seen this Hashgraph talk once. It's hard to follow. And it's, of course, not a blockchain or something. So it's not cryptographically linked or something, but it's agreeing on some kind of horizontal scale.
Ali Pasha is an expert in Hashgraph.
Well, it is graphically linked. So if you see more than 2/3 of signatures of other nodes on a transaction, you take this transaction as valid. But then the problem is, how do you know that 2/3 of that you've seen 2/3 of the signatures? So therefore, you need a master node, and this is why IOTA will never work, because they're using the same thing, but they say that they don't need the master node to count the participants.
They still do that?
No, they're currently shutting it off.
Yes, but the problem is, like, it's not possible to shut it off. So
don't tell them. Hey, they have lots of Twitter followers.
I think
IOTA was my personal eye opener in crypto, right? This was the first white paper that I read that I didn't understand after trying a week long to understand it. And for really, this was the first time I realized for myself that maybe I simply don't understand, or people make something so complicated that you're not supposed to understand it anyway, because it's not true. And so, I had my fun with IOTA. And actually, that was the nice thing about Hashgraph, because they, for me, at least for me personally, they were the first to really show the issues of these directed graphs, right? And I explained the issues and how they solve it, which IOTA, like Mario said, never could. But it's a funny world. Stefan, anyway, before I forget, awesome presentation. Awesome.
Yes. Stefan, you had your last slide, and
right, there's actually a last slide behind the last slide.
Yeah, see, show us.
Show us the state of the slides.
Okay.
X,
Just put all the buzzwords on one piece of paper, and yeah,
Great.
Christian and me, we could just read them along, but you can also read them on your own.
Yeah.
What do you mean with off-chain workers?
Off-chain workers. Oh my God. Thank you. This was one of the few words I put on the slide. The other ones mostly came from Christian. Off-chain workers is a concept that that Substrate, for example, is using. If you have Ethereum smart contracts, all the code runs, it's not running inside the blockchain. That's bullshit, of course, right? But it's running during, let's say, the validation process of a transaction. Then you're running bytecode that's stored on the blockchain using your state machine runner somehow. But now you write all the bytecode on the blockchain. Every ERC20 token is deployed on the blockchain. There's lots of bytecode on the chain. And the people of Substrate thought, maybe it's a good idea to not store the code on chain, but just to store the input and the computed proof on chain, and said, okay, we had some input. We have been running some code that had been signed, and the output of that code I also put onto the transaction result. So you don't have to put the bytecode on the chain. You only put the inputs, the signature of the code, and the output on chain. So you can prove, if you have the code, that this code has run on some people's machine. This is something that Substrate is doing, and they're massively proud of having achieved that. I'm not sure if this is really working. Now, the problem is there are chances that you don't know the code anymore because the code is not running inside the chain. This is, I guess,
and the code cannot be validated by the nodes, right?
Precisely. So you need the real source code to validate that transaction, because you have to run it off chain.
It's really a complicated field, yeah.
I've never heard of off-chain workers. I've heard of
one of the
second layer
central
solution.
pieces of the frame architecture that makes up Substrate that's run by Polkadot Consensus.
Yeah,
the parity
don't really
people
care about them.
are crazy people, right? But they have some good ideas, I guess. I just put the word there.
And everyone here knows that SSI means server-side includes?
Nope.
Probably not, but I would like to. What does SSI mean?
Self-sovereign identity.
Ah, okay. Thanks.
Server-side includes, that's cool.
Server-side includes, it's lovely.
What are you doing back?
You're not that young, Tino. You're not that young.
It's true.
Yeah.
Old school.
Very cool, very cool.
20 years ago, it meant server-side includes, but 2020, it means self-sovereign identity. Self-sovereign identity is quite unrelated to a database.
But this brings us to the point where we started this meetup or the discussion, right? Structure, finding structure in things and interpretation of each individual. And when we thinking back to your slide of your history, Stefan, of databases, if we would ask someone in the 17th or the 18th, what is the database, right? And the guys from the 1916 would say, no, we have linked data. What you are having here with the relation is not a database. So what if now we are in the same situation that we have a reference of the past, a concept of the past, what a database is, and now the definition or the meaning of database evolved because most of the people, or not most of the people, but people who try to link with something they understand, who are not coming from the technical area like some of us come from. They say, okay, this is a database, right? Because they have some attributes which they understand as a concept, because they don't see or understand fully of it, like all the components, like you have cryptography, you have consents, you have BFT, and all this, what you have shown us in this meetup. So maybe like in 10 years, it is a database, right? But not now, from our expert technical background. So
I would definitely like to add or to emphasize, this is my personal opinion on the question. This is not the final answer.
No, sure. But I
could...
just want to challenge that the concept we have right now, what a database is, and also your definition is that the word database will have probably another meaning in 5 or 10 years, because maybe hopefully DLT or blockchain become a common thing, like relational database has reached to in the 90s.
Yeah, I mean, of course. I mean, first of all, we would like to talk about database aspects, but blockchains, of course, I mean, are you crazy? You cannot store the world state forever. This will end up in a catastrophe. So you have to do something about it. Of course, you can shard that and you can invent these parachains and whatever, but it's actually a crazy idea. This is why I personally am thinking, okay, what do I really need blockchains for? And so on my personal learning level, I would say I only need the blockchain to guarantee that at some point in time, there was some truth in the world. I'm not interested in what the truth is or something. I only need to anchor that timestamp. And this is actually something, this is not from me. This is an idea of these people. Ceramic is doing that. This is also completely decentralized. Everybody shouts document changes in the world. Everybody has changes all the time. But there is every half an hour an anchoring service saying, we have built a nice Merkle tree here. And the proof I'm putting on the blockchain. So you can prove that at, let's say, 5:30, the truth about your document was that one, because that one has been written on the blockchain. This is what a blockchain is really good for, like proving that at some point in time, there was some known state or some known event.
I'm looking at it from a legal perspective too, as I have a master's degree in law, and it's also how I position a blockchain. It is to know the truth in tempore non suspecto. In a moment when nothing is wrong, then you store the truth, so that later on when things could go wrong, you can go back in time and see what was the truth back then. Did I say the sun was purple? Yes, because it's on the blockchain. Well, there is a proof on the blockchain that I said that the sun was purple. And I can't deny that I said it. I can't deny that I said it then. But I can say something else today, but I can't deny the past. And that's very powerful from a legal perspective, because that's the only thing. You go to court, people disagree on what has been done in the past. You don't disagree on what happens in the future. You disagree on what happens in the past. And if you could exclude that by storing the truth on a ledger, we will win a lot of time, a lot of money to make things more efficient. So I really concur with your, you could call it a simplistic view or a very basic view on blockchain, but I think it really nails the essence. Everything else it's building on top of this simple bare necessity to have the truth at a certain point in time stored.
Right, it's mostly about timestamps and ordering, but it's of course very convenient to have this system like Ethereum, right? If you put the code on the chain, everybody can check the code more or less. If you have the API, everybody can check about the state of a certain smart contract. It's all written there if you execute it. This is really convenient. It's really fun, but it's really expensive. And this is why.
And it doesn't really add value. 30% of the contracts on Ethereum have the option to store your money somewhere else without you knowing it. There are so many bugs in there, nobody seems to check it. So it could be true, but it's not. It's still people that are running it, and it's too complex for people to put it to good use, apparently.
Cool.
I'd like to add some thoughts about this database. Is it the database? I'm relatively new to all the blockchain topics and stuff, but I'm have some experience with cloud native technologies and something like Kafka, etc. My feeling is that the term database itself might, as I think also the presentation showed, is a little bit fuzzy in explaining what something is here. And maybe it's an interesting question to try to go some steps back and saying, okay, is it something with state? Is it something with storage? So probably we store something. So at least we have something like a data storage or something like that. And then the try, because I don't know if there's a like finite definition of a database, but trying to determine something as a very specific thing normally needs to like a definition, like a very on-point definition of something. And I'm not sure if like a database has this perfect definition, or it is this perfect definition of it has transactions and everything. So, and then can this question be directly answered?
Thanks, Tino. I think you joined us a little bit later, right?
Yes.
And Stefan, he introduced us to those definitions, and we had also talked about data itself, the history of database, and so we have a common, I think, a common sense or common view on it, what theoretically is, and everyone has also explained how they understand what a database is. So we try to have a same level of understanding.
Which is
okay. Yeah. Sorry, I didn't.
No. Just want to share it with you.
And I think actually, it's actually the most important thing we need to learn for the future is really we have to ensure definitions are shared. Our biggest problem at the moment in the world we live, the state of definitions is not in consensus. We use words that we interpret differently all the time. It's really everywhere now, and it's really dangerous. And I think it's good that Tino and Stefan and Marius and everybody that we that this, we saw this here too, right? It starts with database, it goes to what is a blockchain, so it's everywhere, and I think it's very important to try to stop this. Yeah.
I think you see that it's just a thing that moves. It's not always the same. The interpretation changes from relational databases or pointers to magnetic tapes to the NoSQL. It's a huge difference, but still we call it a database because it's there. Now blockchain could be a database too, just as a word.
Yeah.
Well, it just has a technically different appreciation.
But what I'm trying to say is it's important to at the beginning, like Jan and Stefan and Christian tried it here, to really set at least the room of interpretations, right? So that we are able to communicate. Yeah? At the moment, people are saying AI and they mean a script in Excel, right? And it's getting, and we have this in politics even worse now, right? And so it's very dangerous, I think. Yes, but I understand what you're saying, Kuhn. It's of course it's natural, but I think when discussing with the people, we have to educate ourselves to do this definition.
I totally agree, Sam. Especially in this field, we have that some think they are the expert and know have the understanding and not listening. So that we try to listen and try to understand the other definition or how they do the interpretation, so that we have an overlap of understanding. Even you come from another field, so we have people from law, we have people from economics, and then have this discussion. But yeah, it's always the question of time, that most people don't have the time or don't want to listen because there are other incentives.
And Sam, I also want to agree with you. Yeah, you're totally right. The problem is nowadays that we have got now not really a definition for anything, and this was also the case why we wanted to do this meetup here, just to show that to define something like a database, it's really not that easy. It's not trivial like this. And you can see it on this page here, where some of us have and some others have had tried to give an explanation or the definition. And this leads us to this point that some of these definitions are contradict each other. So we just I think that this meetup had had not have the goal to define what a blockchain is or what a database is. It was just to show some aspects of the technology and the technology itself and what a database is. And I think this whole discussion reminds me also about an article I have read about Kafka, where the question was, I think Stefan, you shared the link to the post. It was about if Kafka can replace a database. So in this specific article, the author also started with defining what different databases do, what are the strengths and what aren't. So it's a really big field, and it's just great to have a conversation about it. Thanks.
Did you put it on Twitter, you mean? Or maybe I shared it in our conversation on Twitter, right? Maybe we can look that up. But this is one article I would recommend to everybody. This is explaining what Kafka is doing under the hood and how it relates to consensus and what is Raft. It's a brilliant article. It's really long. Read this one, and you'll most likely know much of event-driven.
So I think sorry, Marius, the entire exercise is that we most of the time in our meetups, we always come to the point of discussion and definitions. Even Christian and myself, if we have like our beer together with a peer-to-peer or discussion, we typically try to ask, how do you find X? What do you think of B? So what's your understanding of Z? So then we have a common base to talk, because usually we have a discussion without an ending, because we have a different understanding of the word. So Mario, sorry.
Yeah, so I think I don't know if Roland is
Ronald, he's already he left already.
He's already gone. Yeah, that's a bit sad, because he had like a really nice point in the beginning of the discussion.
Yes.
About why actually we need this discussion and why should we have this discussion. Because I think it doesn't, for me at least, it doesn't make sense to talk about terminology and what do we benefit from like declaring blockchain as a database or not declaring blockchain as a database?
Shall I will try to answer that question from my own experience. I've been involved in 25 to 30 blockchain projects with different enterprise blockchain with different stakeholders. And you know what happens every time? The tech guys, they start to discuss about the technicalities of the blockchain, while the business people are indeed wondering, what the fuck is going on? Why are they fighting? And then they conclude, if the tech guys can't figure it out, then we don't need it, because we don't know what we're getting. So it is really important to get it nailed, more or less, or to agree to disagree, so that we can go forth, so that the technical people can go forth, that they don't need to insult each other or make a fight in a room with the CEO because they can't agree on whether a blockchain is a database or whether it's distributed or decentralized. But that's actually what happens every time again. And then the business people have to decide, and they usually decide to do nothing because the tech guys, they can't agree. So let's not do it.
Yeah, but from my opinion, it always boils down to the question, do we really need a blockchain for that?
You know the answer from Dave Birch? No.
No. Simple, right?
You need the blockchain? No. Okay.
I would add, Marius, I understand what you're saying. I really do. But I would add that, like you said with IOTA, it's important there's a certain need to understand really, to be able to separate bullshit from interesting experiment, right? And for that, not everybody, but at least some people that are not only developers need to try to understand the concepts in a way that they can evaluate them, right? So I think it's not necessary for the value of a blockchain, but it's necessary for for us as humans, because there's a lot of scammers and a lot of people that just want to make the quick money, and somebody needs to at least try to understand if it's really an interesting experiment or if it's just fraud.
Yeah, but
Yeah,
I still
I
like
can
this
see.
this question: do we need a blockchain? Because some people hear the question, but what they really hear is, do we need a decentralized database like Ethereum?
Yeah.
You need a blockchain, and this is, I think, also part of this presentation, that at least something that I would like to explain. You need the blockchain if you're truly decentralized and you cannot trust anybody. Then you need some, and you cannot even trust the timestamps. So you need something that is finally agreed on what's the real ordering of events. And I guess you need Byzantine fault tolerance. And this is only achieved through blockchain technology. There is nothing else that can guarantee that. And then you need this event-driven database system, let's call it. And this is where I would like to cut and say, okay, this is a blockchain aspect. This is just event-driven state machines on top of this blockchain.
Okay.
I tend to disagree a bit on the full decentralization. I think you can use a blockchain whenever you are unsure about who will actually store the truth in a truthful way. If you don't know, if there is not enough trust, like between banks, they have systems we have live projects in the financial sector where they use the blockchain to store the truth. And then you could say, well, it's not decentralized at all. It's 3-4 banks collaborating, or in Italy on Corda, to run how is it called, Spunta or something, where they share a log of transactions between a bank, and they used to do it all term by turn. So one bank was in charge for 3 months, and then the next bank. Now they use a blockchain for it. It's decentralized. It's not really decentralized. It's 17 banks, but they don't trust each other enough to have one person in charge. Well, they did it in the past. Now they use a blockchain, and they know that whatever is stored there will be considered the truth.
Yeah,
and I don't think you can reach that with another technology than a blockchain, apart from a central database, but then you need somebody in charge, and then you don't trust that one. So then you have you just keep turning in circles until you decide to have an approach where there is no clear owner of the data or owner of the system in its totality.
I think that this is the whole point of blockchain, right? This is also what Satoshi wanted. Like, okay, if you don't have a bank, because banks are bad, we need something else. And everything else in the classical way of thinking can only be a bank. But we don't want a bank, so we need something else. And then you have the system where, well, we just run something. Nobody knows what's going on, but we all can trust it.
Yeah,
and of course, I mean, banks they can trust each other, I guess, if they have a phone.
No, they don't trust each other. Really, why should they?
They don't trust each other.
But they use a blockchain to store the transaction logs between them so that they can validate it later on when things go wrong. They're not afraid of the double spend. They're afraid of information lost or errors being made, human errors, transferring data. And that's why they use a blockchain to validate what happened in the past. You sent me file X. Well, apparently now I get file X, file Y from you, but that's not the thing I received in the past while you claim it is. Look, I can prove it isn't true. And it's not me who said it isn't. It's you who registered the hash, and we all validated that it's a hash. So you basically incriminated yourself.
But yeah, I understand what you're saying, Koen, but for me, that's simply kind of a hash system, right? And you have to, it's a combination of cryptography, like a hash system, and governance, right? And I agree that a blockchain can be like is like a solution that works because it has everything that you need. It has the cryptography part, and it has the governance part. But I would disagree what you said that is not possible in a different way. You could like they could form, I don't know, a cooperative with the governance structures and use
then you have
hashing.
to trust. You have to trust in this structure.
Yeah, exactly. Yeah.
And why would you trust? Because, well, you don't know what the others are doing there. It's really the Byzantine general problem. They're all sitting around the city, and they don't trust each other, and there is nobody who's coordinating it. But if one general is coordinating it, then we'll all wonder, what is this general trying to achieve? So
Yeah, at least in Germany,
it's a recursive system. Then they just don't trust whoever is going to decide. So they need a neutral party, and the technology is neutral. So that's why it really works, in my opinion.
And
you're
you have
right
still
about
social engineering, right?
It is?
Yeah.
It is what? Yeah. No, I didn't catch that.
I would add to Sam's point. If you have a corporate, cooperative, you have still people, right? Humans, and you see that it doesn't work.
Yeah, indeed. And if it's people with access to the data, then you can't trust it. If if in a bank there will, if the banks collaborate, there will always be a central instance to monitor the blockchain itself, to decide upon when to upgrade, which nodes can go offline, how to onboard, how to offboard. So there is still a central instance who is taking, who's doing the actual identity-related work and permission-related work, but they don't have access to the data. They can't modify the data, and that's the benefit that the banks have. And in the first phase, it's indeed an audit log, but they all have the same procedures too. If they then pour the procedure into smart contracts, then they really make use of blockchain in a very good way, in my opinion. I wrote a small article on that on LinkedIn, and on those 2 steps, audit log and then smart contracts, where you basically can do with an audit log ex post validation. After the actions, you can validate what happened, and with adding smart contracts, you also have ex ante validation. You know how the process will run like, and if I toss data X in the process, the result will be B, because you know the entire process and you always know how it will run.
And Koen, what you have told about the banks, it reminds me of what the Deutsche Bahn is doing, because we had also a speaker from the Deutsche Bahn who was explaining what they're doing with blockchain. And one main part were some kind of distributed or decentralized ticket system, because here around Mainz, there's the Rhein-Main-Verband, I think it's called. So the problem with it is that they're putting a lot of effort in analyzing which type of transportation vehicles that people are using or taking. So after all, it's about shares, about which organization does get what from the shares, from this ticket price. So it's about money. And the idea here is that they're putting all the data in some kind of blockchain-like system. So this is the independent entity, what you have told, you have told about, mentioned, Koen. So now we've got a databases, not a database, some information that are reliable. So they don't have to spend a lot of money, and it's a lot of easier and better for all.
They trust each other enough to collaborate, but they don't trust each other enough to have the data administrated by one of them. Right. That's basically the issue.
Yes. And especially also the cost and the probability, what they shared with us is that if you are a small company running like a bus, or you have a train, so it's privately owned under the umbrella of the Deutsche Bahn, that it can be that this company will get insolvent after the calculation has been made. So they don't get paid, right? Because the calculation takes time. It can be like, for example, in the future, in 3 years, they get insolvent because they don't get the money what they expected, because the calculation is different from what was planned. So if we have a technology or something which is the state or the truth, this can be resolved pretty early. So it's not a human being there who do the calculation, or with human added services. So that's much more reliant than the current process and current system works.
It doesn't differ much from an insurance policy then. You just use blockchain in case things go wrong.
Yeah.
Now you have this insurance policy, which is a blockchain, and then you know that things shouldn't go wrong anymore. And when it does go wrong, you know who to blame. Actually, you know there is liability connected to it.
But you maybe don't really need a blockchain as a decentralized consensus for that use case. You only need lots of distributed, let's say, Kafka nodes or something. If you run enough of them on enough
true.
computers, you can achieve more or less the same.
True, but it will be quite. Yeah, true. It's indeed there is another solution for that, but I don't know if they like it that much. With, for example, in Belgium, a project in the insurance sector where we digitalized the green card, the proof of insurance for a car. So it has a lot of data on it, and when you have to show it, everybody knows where you live. So we thought that's not needed. All you need to know is its license plate insured or not, green or red? So we built a proof of concept, and then we went to other banks, and they all said, yeah, but we don't need it. We can do this in another way. We already have a central database. And which problem are you solving? The problem we're solving is not in Belgium. The problem is if I drive into a truck from Bulgaria, this guy also has a proof of insurance, but I can't read jack shit of it because it's written in Cyrillic. But I still want to know whether he's insured or not. And I have to rely then on a green piece of paper with things I don't understand. If I would be able to scan his license plate, then it would be okay. But then my insurer has to trust the Bulgarian insurer to tell the truth. And that's a liability I cannot take, but my insurer can take it. So they don't trust each other enough to rely fully that the Bulgarian insurer will say, yeah, sure, he's covered. And then my Belgian insurer says, hey, the Bulgarian guy says it's okay, so it will be okay. No. That's what they don't like. So they trust each other enough to collaborate. But if then later on it would turn out that the Bulgarian insurer was lying and that the truck is not insured, then the Belgian insurer will say, look, you are lying to me. That's when the liability kicks in. Yeah, so it is a little bit more complex. And if you're spreading your systems around, I don't know if you won't have a discussion about the data that the Bulgarian insurer will say, yeah, but you're cheating on your data. And with a blockchain, you can really exclude that up front.
You exactly described the case when you need the blockchain, which is totally right. I was talking about when you don't need it. You don't need it if you know all the people. If the Bulgarian and the Russian and the Australian, all the people are sitting in the same boat and they have phone calls and they know them by person, you very likely maybe don't need the blockchain. You need it in exactly your case. You know, you're the Belgian guy and now you hit this truck driver in Bulgaria.
It's true. I said the same, like, why is it so hard to get blockchain projects going in Belgium? On 1 square kilometer, we have every bank and every insurer. If there's a problem, you walk there and you tell them, I have a problem. You don't need a blockchain to tell that. So as I do agree there. It's well, when people ask me when to use it, I say when you plan to scale, when you plan to go cross-border.
Yeah, exactly. When there are suddenly participants in the whole system, you don't know who that is, and you just want to trust the thing he says.
Yeah. If you don't need scale, you don't need a blockchain.
Blockchains are scaling very badly.
yeah, which is an issue, huh?
Absolutely.
So it's like killing its own use case, but
we're working on it.
I thought Ethereum was not meant to scale, isn't it? Vitalik said it in a podcast somewhere, that they never conceived Ethereum to scale.
Well, yeah, they're like second layer solutions, and it was always the idea that, like, he wasn't so naive to say that the base layer will ever scale. Like Bitcoin will not scale. Like you need, I don't know, 300 gigs or something to run a full node.
Yeah, you can prune it to.
Yeah, but then you lose some of the things. Yeah. And this is basically what we're discussing right now. Like there's this Genesis EIP that does basically this, like prune all the state away, all the old transactions, and you only have like a current state from the last like 1 million blocks or something. So yeah, and then there's like other ideas like this zero knowledge rollups, ZK rollups stuff. State channels.
Ah, there it is. The trilemma.
Found it for you. But state channels is actually, this is one of the brilliant things, but I'm also not sure if this is working or solving all the problems. It's definitely solving the speed of well-known persons transactions and building this channel of, we can now transact some certain kind of data, but I'm not exactly sure if this is like a universal solution for scale problems. I'm not sure.
Well,
It's
there's
not.
no universal solution. There is no,
There's
at
none.
least, you know, I mean, Marius
That's
is really working hard. I trust him, but generally, in my conclusion, this is exactly the thing. The trade-off is not worth it, right? And I remember Vitalik had very many different solutions, or at least started very many different discussions from another kind of ghost. I don't know if you remember, Marius, like a proof of staking kind of thing, sharding. There
Oh, you
were
mean
lots of
Casper?
things going on.
Casper, the friendly finality gadget.
Exactly, Caspar. Thank you. Yeah, the other ghost. Yeah, yeah, and so yeah, what I think is really that there are certain things that are so cool that you shouldn't touch them, like that we can find a state without trusting each other. And then there are other things that you can solve, but they're always a trade-off. Like Lightning, it's a great solution. It's amazing, but at the end, I have to trust again to the system to work, and it's not the same trust level that I have with Bitcoin itself. So yes, you can do it, but there's a trade-off. State channels are a trade-off.
Security.
Yeah. So
Actually,
Stefan, maybe shortly to your remark about state channels. I've been working on a state channel startup for 2 years, I think. It's called Perun, and
I remember.
yeah. So yeah, there's like a big trade-off with a state channel, and that is economic cost, because you have to, like, if you open a state channel with 3 different people, then you have to lock 3 times the collateral in every channel, and you always have to lock this for a period of time, so that if someone cheats, you have enough time to go to the blockchain to say that he cheated and to get your money back and stuff like this. So there are big trade-offs with state channels. And there are also trade-offs with this this rollups, which is basically like a central operator he has to, like, you send your transaction to the central operator, and he has to apply it. But if the central operator misbehaves, you can always get your money back. So your money is not like, you will never lose your money, but you can you can lose
Data.
no,
The
you can
transaction.
lose time. You can lose time. So like you have to go to the blockchain and say, hey, the operator didn't respond, and then the operator can say, well, I did, and then you have to say, okay, here's a proof that you didn't, or something like this. So
So you have to
there are
delay.
trade-offs.
Yeah.
And I think those trade-offs, they are all based on this scalability trilemma, because you can like this cap trilemma, not this one, the other one, the normal cap, because it's very hard to get consistency, availability, and partition tolerance.
Consistency is actually the timeout problem, right? So it takes a while until the blockchain says, yeah, okay, now after 6 hours.
Yeah. So yeah,
right.
that's
6 hours later.
So yeah, in blockchain, like in public blockchain, you solve availability and partition tolerance, but you only have like eventual finality. So you don't have consistency in the first thing. So that's the trade-off we do in blockchain.
Yeah. yeah, you probably all know why it is 1 hour in Bitcoin blockchain. It's a time limit of 1 hour before you can consider your transaction to be, well, secure. Do you know why it is 1 hour?
Because
Yeah,
it's 6 blocks?
yeah, it's
The longest fork ever was 6 blocks.
Ah.
So it's like the Titanic sinking. For the
the
Titanic,
heuristic,
no boat
yes.
sunk.
Yes.
And so now we have 6 blocks. So, well, it's okay. Let's wait 6 blocks because it never was longer. Well, it's a bit
Yeah,
an arbitrary amount of time to wait because, in fact, you should wait indefinitely. But, well, that's also not that practical.
All right, but let's summarize the results or opinions of the question. Do we need a blockchain? I think the consensus is maybe not, but actually we have to ask ourselves if, or the right question would be, do we like to use a blockchain?
But isn't the question, is a blockchain a database?
Right. But
Don't start another discussion.
I think it's too late already, Christian. We have now like three hours, almost 3 hours is a typical Mainzer crypto community meetup. So not whether we need a blockchain, but is a blockchain a database? So we at the beginning had everyone a concept about this question. So did it resonate, or did you shift your initial concept, or do you have now another opinion? I think good bit if we triggered some thoughts and that you think, okay, we need to investigate or learn more something, and the concept we have in mind changed a little bit, right? So not being right or wrong, but that we learn something new and go out and then question all this big newspaper anyway.
Maybe you have more arguments now at hand if you talk to that FAZ people who are writing that it's a decentralized network of encrypted databases.
They just put everything in one sentence they found.
Yeah, and they missed the word IoT and AI there.
Yeah.
If I look at my point of view, I think that I realized that it's more metaphysical or philosophical than I initially thought. So I really appreciate all the detail about databases. There are things in there that I've long forgotten, actually, like the ACID. I still remember the CRUD, but ACID indeed. It really made me think, like, well, while initially I stated, yeah, blockchain is a database with some extra functionalities, and it's actually the other way around. If a blockchain is a database, it lacks functionalities. So it's probably not a real database on a technical level, while, as you said, you can still use it as one if you look at it as I can retrieve data from the past point of view. So it's really really appreciate the entire conversation, as it made me fine-tune my thoughts and made me realize that I shouldn't be that stern about my opinion against everyone.
Thanks. Anyone else would like to share what the discussion triggered in your mind?
I really appreciated the presentation. It's really, it was really great, Stefan. Really awesome. And for me, it reminded me of this idea that the actual true, like, USP or the core value of Bitcoin and Ethereum is really this finding a state we can agree on without knowing each other, right? And I think if we think more about businesses that need these kind of this kind of solution, then you find great business cases. But yeah, that was the interesting thing for me, to come back to this idea, to hear it from somebody else, and a very great group. I mean, yeah, I learned a lot. Thank you.
Thank you.
Yeah, I also very much thank you for the presentation. And I guess if I had to define the tech industry in one word after this evening, I would say trade-off.
Trade-off.
Yeah.
It always is a trade-off.
Yeah, you always have a compromise.
Yes. First the compromise, then the consensus. Anybody else?
So from what I observed in the last 3 hours, and what I really appreciate is that as like 50% or 6% of the participants here come from the tech background. So what Kuhn triggers me is that you come in with the perspective that you have the experience of those 20 or 30 projects. And as soon we go into technology discussion, you come in and kick in from the law side and you say, hey, but in this case, we need something which, right, in the real world, or what you have in discussion with companies, with clients. So I don't have this view only in one project. We have once, but I see that we need more like from other fields to discuss technology. So we that law, I think, is one point from the legal perspective to not to sell it, but to explain why it is important to need this technology, right? So I really like that to get in contact more with people, not only from the technology side.
Yeah, so if I can quickly jump in on that, I think it's because people involved in technology, they're always very positive about technology. And when you look at the web, it still has this little vague anarchy thing connected to it, like, yeah, well, but we can still cheat our way around it, and we're not allowed to share, but we still do it on the internet. This afternoon, there was a session about blockchain in healthcare from the EU Blockchain Observatory, which is now hosted by the University of Nicosia and a few other startups from Cyprus. And there were two people talking about live projects in healthcare. They make millions of savings in hospitals, and they state, we only can do this because it's a private permission ledger. There was one blockchain architect, and he said, yeah, but you must have examples of public blockchains, because if it's not public, it's not really a blockchain. Then I'm like, dude, you just heard how they save money with their private permission ledger. What is your problem? But for this technical guy, it's a bit more, his opinion is it should be a little bit anarchy. It should be public, because that's how the internet works. That's how tech people must do it. That's where the future is. Well, the people from actual projects that are actually working, they say exactly the opposite. Then I wonder, why do we have this discussion there?
Yeah, and this totally. So this goes back to the point of what Ronald said, right? In this point, do we have any value from this discussion, right? So if this has value for the use case or the project, so why going to the extreme, right? So that's getting to the point of the definition of what Sam said, okay? Because they have concepts in mind, they want to be right and not wrong, because they have this dream in their head.
Yeah, it's Boolean, it's true or false.
Yeah.
If it's not true, then it must be false.
So there needs to be. So we need trade-offs, right?
Yeah, indeed.
It was always right.
Yeah,
indeed. But for a computer, it's either right or wrong. So it's understandable that technical people most likely or more often think in black and white. I mean, I really appreciate the discussion on that account. That you all show more than black and white, but also look for the gray zones.
Yeah. Great. So I think let's wrap up. It's almost, okay, now exactly 3 hours. Appreciate your time, and also Kuhn for triggering the initial discussion with Chris and me in the first call, and Stefan, that you are kicking in with on Twitter, that we have at the end this meetup, and the preparation of this meetup with your content, with your knowledge from Ethereum, and also your tech background. And this thing is recorded. I try to cut it in 1.5 hour. And hopefully see you all again. We have this meetup on 6th of October about open law. This is also a startup. They try to revolutionize a little bit the legal world, merge blockchain with the legal and commercial world. And Jakob, I see you are here. You joined us later, right?
Yep.
And we have someone, I think he's a legal engineer from Open Law, who will give an introduction. I really try to complete a small demo app, which I try to code, but I have still some bugs and also open things I can solve right now with their API from Open Law. Hopefully I can figure it out, and then Jakob will talk about something from a legal perspective. So on 6th of October, we'll have this meetup, and hope you see some of you guys there. And with Coding Earth, hopefully we have again a cross community meetup. Happy to have it more not only a Mainz thing, and we cross the borders.
Well, for everything, the main issue on Coding Earth is we have to find topics besides blockchain. But
yeah,
we happily join.
Yeah. Okay. So, guys,